Ignition sequence.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
One small step for man, one giant leap for mankind.
1, 0, and lift off.
Mission complete, Houston. After serving the world for over 30 years, the space shuttle earned its place in history and has come to a final stop.
Einen Tipp für alle, die sich ein einzigartiges Himmelsschauspiel nicht entgehen lassen wollen. Leider ziemlich früh. Es lohnt sich aber, den Wecker zu stellen. Denn die Venus, unser Nachbarplanet, schiebt sich vor die Sonne. Venustransit sagt man dazu. Auf der Insel Rügen kann man das morgen in Deutschland als erstes sehen, gegen 4:30. Und wie es dann weitergeht, das zeigen wir Ihnen jetzt auf der Karte. Die Berliner werden den Venustransit schon ab 4:46 Uhr sehen können. In Wien wäre es 4:56 Uhr soweit. München und Frankfurt 5:16 Uhr und 5:18 Uhr. Und die Züricher können sich ein bisschen mehr Zeit lassen. Um 5:31 Uhr sollten sie mal aus dem Fenster schauen. Und in Genf käme man um 5:45 Uhr in den Genuss. Also lassen Sie sich das nicht entgehen. Den nächsten Venustransit gibt es in unseren Breiten erst wieder im Jahr 2117. Sollten Sie es denn noch verschlafen? Die Profi-Astronomen von der Europäischen Weltraumbehörde ESA bereiten gerade alle vor, um das Spektakel auch in unsere Wohnzimmer zu bringen.
Im Weltraumastronomiezentrum der ESA nahe Madrid laufen die Vorbereitungen auf Hochtouren. Die professionellen Sternengucker wollen den Venustransit nicht nur beobachten, sondern auch in möglichst viele Wohnzimmer bringen.
Wir haben hier 2 Teleskope. Eines ist ein klassisches optisches und ein spezielles Sonnenteleskop, das nur zur Beobachtung der Sonne verwendet werden kann. Es arbeitet in einer sehr schmalen Orange-Bandbreite, sodass man wirklich sieht, was auf der Sonne vorgeht. Wir haben noch 2 Expeditionsteams losgeschickt, eines nach Spitzbergen und eines nach Australien. Von dort werden wir auch Bilder übertragen. All das gibt's auf einer Webseite.
Und das sollte man sich nicht entgehen lassen, weil es so selten stattfindet. Denn die Umlaufbahnen von Erde und Venus um die Sonne lassen nur etwa alle 100 Jahre eine Konstellation entstehen, bei der dann zweimal kurz hintereinander, im Abstand von 8 Jahren, Sonne, Venus und Erde in einer Achse stehen. So zuletzt geschehen 2004. Bis zu diesem Zeitpunkt hatte kein lebender Mensch das Spektakel je gesehen. Aber beschrieben wurde es immer wieder und es hat über Jahrhunderte Forschergeist geweckt. Edmund Halley war einer der ersten, der die Möglichkeiten einer solchen Beobachtung erkannte. 1716 dachte er, dass man mit Hilfe des Venustransits Mitte des 18. Jahrhunderts den Abstand von der Erde zur Sonne bestimmen könnte. Da man dafür Daten von verschiedenen Punkten der Erde brauchte, löste er das erste globale Wissenschaftsprojekt aus. Über 100 Jahre später wurde dann beim nächsten Transit bestätigt, was heute moderne Radarsysteme noch genauer messen. Die Sonne ist von der Erde etwa 150 Millionen Kilometer entfernt. Über die Venus wissen wir inzwischen auch etwas mehr. Die Sonne heizt unserem Nachbarplaneten ziemlich ein. 400 Grad macht die Venus zu einem ungemütlichen Plätzchen. Aber auch sonst ist sie etwas ganz Besonderes.
Die Venus braucht 220 Tage für einen Umlauf um die Sonne. Der Tag verläuft in umgekehrter Richtung und dauert 240 Erdtage. Das verstehen wir überhaupt nicht. Alle anderen Planeten drehen sich wie die Erde in unserem Sonnensystem.
Auch das Weltraumteleskop Hubble soll den Venustransit beobachten. Weil seine Instrumente so empfindlich sind, wird es nicht direkt in die Sonne schauen, sondern Richtung Mond. Dort registriert es morgen früh den vorbeilaufenden Schatten der Venus.
Und wenn Sie morgen das Vorbeiziehen der Venus beobachten wollen, denken Sie daran, sich die Sophie-Brille aufzusetzen.
Von allen Planeten unseres Sonnensystems ist die Venus der Erde am nächsten. Sie umkreist die Sonne in 7,5 Monaten. Sobald sie sich exakt zwischen Erde und Sonne befindet, taucht sie für uns als kleiner Schatten vor der Sonne auf. Da die Umlaufbahn der Venus leicht geneigt ist, passiert es aber eher selten, dass sich beide Planeten auf einer Höhe befinden. Der letzte Venustransit war 2004. Den nächsten allerdings gibt es erst in 105 Jahren. Und für morgen früh bitte Vorsicht, nie ohne Schutz direkt in die Sonne schauen.
Wohl die letzte Chance für uns alle, dieses Naturereignis zu erleben, denn das nächste Mal passiert genau das erst wieder in 105 Jahren. Vor allem Wissenschaftler, Astronome waren schon immer wild darauf, die Venus in genau dieser Position zu erblicken und zu erforschen und ihre Berechnungen perfektionieren zu können. Michael Schmidt mit einer Art Kulturgeschichte über das Phänomen Venustransit.
Wie weit ist das Weltall? Die Astronomen der frühen Neuzeit hatten die Erde zum Anhängsel der Sonne degradiert. Aber über die Entfernungen jenseits der Erdkugel wussten sie wenig. Sie hegten aber eine Hoffnung. Und ein Himmelskörper, seit Urzeiten in vielen Kulturen nach den Göttinnen der Liebe benannt, wurde zum Wissenschaftsparadigma. Genauer gesagt, sie hofften auf die Hilfe des seltenen Venustransits, wenn der Schatten des Planeten bei Tageslicht vor der gleißenden Sonnenscheibe vorüberzieht, wenn man Durchgangszeiten bestimmen und Winkel ausmessen kann, um mittels trigonometrischer Berechnungen die Entfernung zur Sonne zu bestimmen. Und heute quellen die Datenbanken über von historischen Dokumenten, Infoseiten, Videos und Astro-Reiseangeboten zur Geschichte dieser Beobachtungen, Messungen und Attraktionen. Wissenschaftlich ist ein Venustransit mittlerweile zwar bedeutungslos, aber als ein Bild von Wissenschaft und von Erkenntnis ist er weiterhin eindrucksvoll als Himmelsspektakel. Nur professionellen Astrophysikern bietet er kaum noch Anreize.
Für das eigentliche wissenschaftliche Ziel, jemanden zu begeistern, das geht, solange es sich sozusagen um etwas handelt, was man bildlich machen kann, was Geometrisches, sagen wir mal. Was man nicht bildlich machen kann, dafür eine Öffentlichkeit zu begeistern, das geht sehr viel schwerer.
Wir wissen, dass Erde und Planeten um die Sonne kreisen. Aber was wir täglich sehen, entspricht dem nicht. Daran haben Wissenschaftler lange laboriert. Erst Teleskope liefern im 17. Jahrhundert die neuen Bilder, die dieses Weltmodell augenfällig machen können. Als daher in einem Dorf unweit von Liverpool der junge Jeremiah Horrocks 1639 ausrechnet, wann die Venus als Schatten vor der Sonnenscheibe vorbeimarschieren wird, geht es vor allem darum, um Bestätigung für eine neue Ordnung der Dinge.
He became convinced that Venus was about to pass in front of the sun. He prepared to observe it by projecting an image of the sun through his telescope onto a screen. Venus was there, a small dot moving across the image of the sun. Whoa! From his observations, he calculated the first good estimate of our distance from the sun.
Man vergisst immer, dass das, was heute an Rechenoperationen für uns der Computer erledigt, dass das alles mal eine fürchterliche Aufgabe war. Ja, vor diesen Rechnungen kann ich nur eine viel größere Hochachtung haben als nachher vor der tatsächlichen Beobachtung.
Gut 120 Jahre nach Horrocks einzelgängerischer Leistung sind die Astronomen im 18. Jahrhundert besser gerüstet als Trittbrettfahrer europäischer Weltmachtinteressen. Im Zeichen der Aufklärung fahren sie in einer Art von internationalem Verbund auf Kriegs- und anderen Schiffen mit, um Himmel und Erde zu vermessen. James Cook etwa beobachtet einen Transit von Tahiti aus, findet Australien und erkundet die Südsee. Allerorten will man die Entfernung zur Sonne bestimmen, mit mäßigem Erfolg. Man will aber auch die Erdkugel verfügbarer machen.
Auf lange Sicht hat alle Wissenschaft für das Leben der Menschen positive Dinge gebracht, unabhängig davon, ob man zu der damaligen Zeit, wo die gemacht wurde und erfunden wurde, tatsächlich daran gedacht hat. Wissenschaft ist eine langfristige Tätigkeit und Wissenschaft sozusagen an kurzen Zielen auszurichten, ist eben zu kurz gedacht.
Wissenschaft also als Menschheitsprojekt, nicht nur als Drittmittelakquise. Im 18. Jahrhundert sind lauter berühmte Männer unterwegs. Keiner, nach dem nicht mindestens ein Mondgebirge hieße, schreibt Arno Schmidt in Das schönere Europa. Und Thomas Pynchon spottet in seinem Roman Mason and Dixon über ein kollektives Gehirnweh, das diese Herren seinerzeit erfasst habe. Venus, Erde und Sonne, das ist ein Vektor der Sehnsucht, den auch die Technik des 19. Jahrhunderts nicht präzise bestimmen kann. Der Nachwelt bleiben zahllose historische Fotos sowie ein bisschen Marschmusik.
Der emotionale Hintergrund an der Wissenschaft. Es ist die Freude, was zu finden. So wie das Einstein auch beschrieben hat. Es ist die Freude, was zu finden. Wenn man wirklich sozusagen es gibt keine schönere Musik als das Geräusch, was der fallende Groschen macht.
Wie ein Metronom der Wissenschaftsgeschichte schiebt sich die Venus als schwarzer Fleck alle 110, 120 Jahre vor die Sonne. Wir können das heute in Zahlen fassen. Aber was sagen sie uns?
Morgen also ganz, ganz früh aufstehen. Gegen 4:45 soll der schwarze Punkt für uns zu sehen sein, wenn es das Wetter denn zulässt.
Welcome back to the Mission Control Center here in Houston, where we now have to talk with us astronaut Mario Runco, who's going to tell us a little bit more about what Don Pettit's going to be seeing on the space station and what we might be able to see here on Earth as Venus makes its transit across the sun later today. Thanks so much for joining us, Mario.
Thank you, Brandy. Thank you, Brandy. Thanks for having me.
Well, okay, so we heard a little bit there about kind of what the transit is, but maybe you can tell us a little bit about your background, why you're interested in it, and why we should pay attention.
Okay, well, first of all, I was infected somewhat by Don Pettit and his enthusiasm for astronomy. My background is earth science, remote sensing, meteorology, and oceanography, and the connection between my background and my previous experience and now is since I was flying in space on the space shuttle, I have, with the International Space Station, been very instrumental with another team in the windows on board the ISS, particularly one, the lab window in the Destiny module. That is a science window for Earth science remote sensing exactly. We had proposed to have that on board in the early 90s, and it is now on board. And I was with the team that produced the Window Observational Research Facility. Dovetailing off of that with the WARF, by the way, is the acronym that's used with the lab window. Dovetailing off of that is the cupola window. We were part of the team that proposed having the cupola on board and its windows so that we could go beyond just looking at the Earth straight down underneath the station and be able to not only use it for operating the remote arm, the Canada arm on board the ISS, and for monitoring dockings and the like and berthings, but also use it for scientific and astronomical purposes, which we are doing for the transit of Venus today.
Have we been able to do that for any interesting events in the past that you would mention?
Actually, the cupola has been in use for quite some time since it's been on board. Primarily for Earth observations and the images that many people have seen probably of the Earth, quite spectacular. However, we've not used it in the mode we're using it now, where there are internal panes, kind of like your storm windows. You have maybe two windows. In this case, there are 4 panes of glass, but the innermost one is called a scratch pane, and that's a protective pane to keep the others very pristine. And that's not an optical quality piece of glass due to the plastic sheet on it. And so that one is going to be removed today for only the 3rd time. Prior times were for ISS engineering evaluations. This is the first time for science. So it's kind of a big event for us in the scientific community to be able to use the optical quality windows to the efficacy that's needed to bring out really sharp, crisp, detailed pictures of items. And in this case, Don is using an 800 millimeter lens, which is about 6 inches in diameter, the aperture. And for folks in real simple terms is the larger the aperture on the lens or the telescope that you're using, or a pair of binoculars, the more it is affected by the window. So as that size grows, the worse the image becomes. So on a smaller camera, a smaller diameter lens, you don't see too much of an effect on the imagery that you might take. But on a bigger lens, the imagery really degrades quite rapidly. So we're hoping to get some really sharp images of the sun. And fortunately, Don, for this event, he knew about it. And I think Don, in many aspects, knows the goings-on of the entire universe in his head, and he planned ahead to bring the solar filter on board to be able to do this.
Good choice. We're excited to see what he
Yes.
gets. Now, I know this is not the first time that the people that we've been around for a few years have been able to see this, but it's the second time, and before that, it had been a long time, and it'll be a long time again until the next chance, right?
Correct. The last time was in 1760s, specifically 1761 and 1769. And at that time, as Don mentioned in the video, there was a scientific a quest for this. This was kind of like among the nations back then, a moon race of the time, if you will, because to be able to measure the transits at the contact points, that is when Venus first enters the sun and then when it exits, the tangency points between the two edges of the planet Venus and the sun, and you could, through geometry, figure out by the distance and the angles the exact distance from the Earth to the sun and Venus to the Earth, etc., and by that figure out the distances for the rest of the planets in the solar system. This was quite a scientific quest at the time, and the English, the Royal Academy, sent out James Cook in 1769. Actually, he left in 1768 from England to sail to Tahiti. And there's only certain spots on the ground that you could, like solar eclipses, you have to be in opportune places to be able to see the entire transit. And the French had sent out an explorer, Le Gentil, which was interesting. And Don mentioned in his video how he was gone for so long. What Don didn't mention is that he left for the 1761 transit, not the 1769 transit as Cook did. And the 1761 transit, he never made it because there was a British-French war at the time, so he couldn't get to India where he was headed to view it. He stayed out, which was what happened to him, why he was out so long, and why he was declared dead by his family when he returned. But he was going to go back to observe the 1769 transit in India. Cook was going to Tahiti, and in 1769 he got there, but it was cloudy, and he missed the opportunity.
That's got to be disappointing.
I'm sure it was for all those years, 11 years he was out. That was the previous one. The last one was in the 1800s, 1884, I believe, was the last one. And then the next one is 2117. And what's interesting, because of the orbits of Venus and the Earth, it happens in sequence well, it's regular, but it's not at equal intervals. For example, the next one's in 105.5 years. The last one was in 125.5 years. So if you go and carry out the cycle, it's 105.5, and then a pair 8 years apart, and then 125.5, and then the cycle repeats that way.
Okay.
That's because of the eccentricities of the orbits that we have.
But I guess we also our the first part of this pair was in 2004.
Yes. Yes. The first one for this pair was 2004. The ISS.
We had a photo just a moment ago.
Oh,
there
okay.
it is again. The Trace vehicle getting some photos of that during its transit in 2004.
And the 2004, from a manned space exploration perspective, interesting. If I might digress for a moment, a piece of trivia is Gennady Padalka, who was on board now at Expedition 30, was on board Expedition 9 in 2004 with Mike Fink. And unfortunately, they did not have a solar filter. Neither of those gentlemen had the entire universe calculated in their brain as Don Pettit does. But they knew about it, and they tried to observe the transit and by indirect means, the pinhole box camera on a piece of paper to project the sun safely. They were barely able to do it because the angles to the sun were just barely visible. The ISS back then was not completed, and it did not have the suite of windows that it has today. We have much more opportunities for viewing in different directions with the windows on board now, which is why we're going to be able to see, hopefully, all of the contact points and even the center point. So it won't be visible the entire time, because even though we don't have to worry about the clouds, the solar arrays on the station as the sun transits the sky and the relative motions, the the solar arrays or the radiators may block the view to the windows that we would need. But that would be very short periods.
Right. And we've got a few different windows that we can use. So we saw the live view of the cupola, which is one of the choices, and hopefully we'll have some good stuff. And you're going to be back with us later in the week, and hopefully we'll get to take a look at some of it then.
Right. Well, hopefully we'll see some of the images that Don takes. Now, his primary goal is to take the images out of the cupola window 1, which is the window that looks to port, and that window will have the scratch pane removed. So it's going to be, that's an optical quality window. The other 2 windows he's primarily going to use for when the view to the sun is in a different orientation is the mini research module 2 that has a port aft-looking window, and then the docking compartment 1, which has a port forward-looking window. So that gives him the suite of view across the horizon for when the sun transits the sky relative to the ISS.
Well, I know he's real excited about the chance to see that in space, but hopefully maybe a few of us can see it here on the ground as well.
Right. If you're fortunate, and the part of the planet that will not see the transit at all is basically centered over the Atlantic Ocean. We are fortunate in North America and South America to be able to see a good portion of it. We will see it later today, starting at 17:09 or 5:09 p.m. Central Time in Houston, and it will progress, weather permitting, of course, and it looks like we will have good weather, at least here locally in Houston. It progressed till sunset, and if you're in the Europe region, European area, and east toward the Indian Ocean, you will see it at sunrise. So they will have seen it. They will see it for their time zones in the morning, and then over the Indian Ocean, for example, it's in the entire transit is visit. So, if, for example, we were going to send out explorers and we were limited to ground observations, we would send sailing ships to the Indian Ocean, as they did at the time when Cook and Le Gentil went.
But we have a little bit better resources now. I know we've got the NASA Edge crew, I think, in Hawaii on Mauna Kea.
Right.
And they're going to be watching it live, and you can actually tune into some of that coverage on NASA TV starting at 4:30 p.m. Central Time today. Again, the transit itself starts at 5:09 p.m. Central Time.
Right.
So if you were going to try and see it, what are some of your tips?
Well, first of all, don't look at the sun. Do the standard safety briefing here. Let's see. I did have a set of glasses here. You could observe in the traditional ways that most people are more familiar with watching eclipses, solar eclipses, the indirect methods as the box camera, the pinhole cameras that I've said. But if you're fortunate enough, you can get a pair of these glasses. They're very cheap, and they're solar filter glasses. You can look directly at the sun with these. They cost about $1, if that. Unfortunately, there's not many places that sell them in most local areas.
So these are not 3D movie glasses?
No. Actually, it's the same companies make these. They just put in the different inserts for the solar filter as opposed to the red, blue, or the polarizing filters that you might use for 3D. These, for example, you can order online, but you would have had a thought ahead of time to get that. Even next day delivery is not going to help you in that case. If you haven't had the good fortune to do that, then another option might be Welders Glasses. Now, Welders Glasses come in a variety of colors, if you will. Not literally, but you would want number 14 Welders Glasses, and those will protect you for looking directly at the sun. Now, in most areas where there might be an interest, trying to buy those glasses now in a Home Depot or a Lowe's or a hardware store, they might be sold out on them. For example, in Houston, when there's a storm approaching, or Florida, and a hurricane approaches, the stores sell out of plywood very quickly. You know, there's a run on those emergency type supplies. And in this case, there might be a run on the goggles for people who didn't plan ahead.
Well, I hope so. I hope that many people are interested and going to be tuning in or watching.
Yes, that would the transit of Venus is, as Don said in his video, is not scientifically significant nowadays. It's historically significant. We might be able, because of better technology and our observation methods, discern some new nuances of information, of scientific information about it. But it is a tool to generate interest in science, astronomy specifically, technology, space, and I look at it in a historical perspective. These transits, as I mentioned, come every 100+ years or so, and they are points in time that highlight the technology of the time. And the next time it comes, who knows what we will be capable of, hopefully a lot more than we are now. And certainly I don't believe the ISS will still be orbiting the Earth. None of us will be here for the next observation. And folks then in 2117 and in the 8 years after that, in 2125, will talk about, as we are today, the history of observing the transits. And what gets me, as being in this control center and talking with you, is the poignant fact that the ISS now is part of that history, with Don and the crew making this observation. It goes along with Cook and Le Gentile and all of that history. So it's a demarcation of time every 100+ years apart. And that, to me, in the continuity, I mean, if you look at online, you could dig up, there's a catalog of transits that goes back to November 1998 BC. Okay, and then it's projected out to 3600
Wow.
you know, something like that AD. And so and here we're in, at least on the piece of paper that I had, we're in the middle of that timeline. So it connects us with history. It connects us with the future.
Great. Well, I hope that in 100 or so years they'll be using the photos that get taken today and talking about how we observe the transit then.
Well, great. Yeah.
Thank you. Go ahead.
I was just going to say that if folks go online and search on transit of Venus, Venus Transit, one of the particular websites is Venus Transit, one word, .nasa.gov, and you can hunt around there. On that website will be some of the images that Don hopefully will have taken by then, starting this evening. And the team is ready to bring those images down as rapidly as we can and get them posted online for everyone to take a look at. Beyond that, there's a whole host of information out there, as I mentioned, and there's, of course, the website also is with the observations and the live webcasts that are going on from the Mauna Kea in Hawaii with NASA Edge.
Right. So to recap all of that, an easy website to go to is just straight to the www.nasa.gov site. It's linked from the front page there, and you can find all the various coverage areas and information sites available through NASA, straight from nasa.gov. And then, as we mentioned, we're going to be covering it on NASA TV tonight, starting at 4:30 p.m. Central Time, and we'll have regular studio updates and also the live coverage by the NASA Edge team from Mauna Kea in Hawaii. So all that to look forward to. Again, coverage starts at 4:30 p.m. Central Time this afternoon, and hopefully we'll be able to talk with you again later in the week and get a recap of what actually took place tonight.
I look forward to that. Thank you.
Thanks so much for coming out. Again, this is Mario Runco, an astronaut here at NASA, and obviously a lot of good information on the Venus transit. Thanks so much.
The last one was less than a decade ago. Before then, the most recent occurrence was in 1882. And the next time, it'll be 2117, when few, if any of us, will be alive to see it. Among the most rare and predictable celestial events, the sight of the planet Venus slowly trekking across the face of the sun has been witnessed by humans only 53 times since 2000 years BC. What about the heavens have these phenomena taught us? And what else might we discover about our place in the universe? during these next 6+ hours. The Venus Transit 2012, next on NASA television.
Good morning, good afternoon, good night. It depends wherever you may be watching us around the world. This is NASA TV's coverage of 2012 Venus Transit. I'm NASA TV senior producer Al Feinberg. With me, Office of Communications colleague Dwayne Brown. And we've got some really cool stuff to talk about tonight.
That is right, Al. I am so happy to be here. And ladies and gentlemen, you are in for a treat. You are going to hear and see firsthand, not just here in Washington, D.C., but all over the world, something that won't happen again for another 105 years. Now, as Al said, I'm Dwayne Brown with the Office of Communications, but I have one of the coolest jobs in the world. I get to work with special people who next to me, and I'm going to introduce him, but the incredible scientists, engineers that do all the incredible science activities and are all right now looking at what you guys are going to see, the Venus Transit, all over the world. First things first, safety for the folks watching this program. Really, really listen carefully. It's been on the internet, it's been on TV and other things. Do not go outside and look at the sun without some protection. We've got these glasses, and there are other types of components, but safety first. Safety first. Always remember that. And go to your internet, and it'll give you some other ideas for that.
I tested this, by the way, yesterday.
There worked.
Just a little orange dot. Very safe.
And again, if you don't have the glasses, tell your friends to come watch NASA TV and www.nasa.gov. We're going to bring you it live and in color, not just here, from all over the world. And we understand that there's now some cloud weather on the East Coast, but that's okay. You may get lucky, but again, you'll see it here and live and in color. Now, you know, social media, for all you folks who tweet, Facebook and everything, join the conversation. And we have the best of the best working this night, and he is going to be busy. Jason Townsend, you ready for the night, man? I know it's going to be, you're going to have a lot of fun with us, right?
Yeah, we're going to have a lot of fun tonight. We're just having everybody follow along. If you guys are online and you're sharing updates and so on, make sure to be using the hashtag #VenusTransit. Also, make sure to follow along on @NASA on Twitter, and to make sure to follow us on NASA Facebook and Google+. So we'll be looking out for good images. We'll be sharing them along on social media. And if you're taking pictures, make sure to look us up on Flickr. If you go online, the group name is Venus Transit. And so add your photos as you take them, and have a good transit. Remember to be safe out there, everybody. And we'll keep checking back with what's trending and everything else that's going on.
And a reminder, Jason will also be keeping an eye on the different NASA missions and the imagery that will be come up. We've got the Solar Dynamics Observatory. We've got Hubble Space Telescope. And what else?
Astronauts, International Space Station.
That's right.
You name it, we got it. But you know who we have sitting next to us now?
I know this guy.
Okay, so I think it's time to bring him on. Now, this gentleman is Jim Green, Dr. Jim Green, and he is the director of NASA's Planetary Science Division. He is the boss. He is numero uno, the man.
In the solar system.
Of the solar system. And so we're going to go right to him, because you're going to start out with Jim, and we're going to have other scientists, but we're starting off with the boss first. Dr. Green, welcome.
Thank you very much, Dwayne.
How are you feeling about this today?
This is a fantastic opportunity to talk about the fascinating planet called Venus. You know, Venus is our sister planet, and we've learned so much about this particular object. Venus is a gift, and it keeps on giving. One of the things that we've learned by Venus Transit is how far away the Earth and the Sun are. And that one unit of measurement, called the astronomical unit, we use throughout the solar system. And it's really changed our perspective of how big the solar system is, how long it takes to go from planet A to planet B. And so it's one of those fundamental things. But that's just the start of what Venus has done for us. You know, Venus was first observed in a telescope by Galileo in 1610. And when he saw it over a period of time, it changed shape in the sense that as it got close to the Earth, it formed a crescent phase. And as it got on the other side of the sun, it had that full phase. And in fact, it looked like very much going through phases of the moon. Now, Galileo put all that information together and determined that Venus went around the sun. And therefore, the Copernicus theory of the solar system was the correct one. And when he started promoting that, because he now had observations of the sun-centered solar system, it changed our culture, it started the modern science, and it changed religion. And we owe Venus that. Now here's a transit that we hope to see. As you look in the screen of the object between us and the sun, that's Venus. That's how it will look. We only see that very rarely, and in fact, the next time that it will occur will be in 2117. Most of us, maybe all of us, won't be here by then. We'll see what happens from other types of science. But Venus is just such a beautiful transit that occurs, and I hope you'll all have an opportunity to see it. So let me turn it back to Dwayne.
Well, Jim, you know, what I want to say, I would be remiss without acknowledging our good friends who actually are, you know, they're down in Hawaii, the NASA Edge guys, and well, you guys have been seeing them, and you're going to see them throughout this Venus transit, but we want to send out a shout out to them. Also, don't forget about social media. You met Jason, and join the conversation, ladies and gentlemen. Jim, Venus transit. We won't see this again in 105 years. Why should we care? Not so much we can go into the scientific thing, but you know, the millions of folks who are going to be watching this all over around, we're going to be showing some of those sites and visiting. Right. Why should the folks care about this?
Well, we care on many levels. You know, from a perspective of wanting to know more about our solar system, here's an occurrence like an eclipse that's very rare, and of course it attracts our natural interest in looking at these wandering objects and where they go. And in this case, Venus is going to cross in front of the sun. So there's the wonder of the phenomena itself. The second thing is that fundamental transit that is occurring is also of scientific interest. We've got a number of experiments that are going on. We're going to be looking at Venus just as it starts its transit, and we see the light from the sun going through the atmosphere. This is going to enable us to take a look at perhaps the temperature and the pressure at certain levels in the Venus atmosphere over most of the disk. Now, we've never done that before in this way, and this is a perfect opportunity for us to do this. Even Hubble will have an opportunity to make some transit observations. So the scientists are excited about it. I hope the public is excited about it. It's certainly an important astronomical phenomena. And historically, this has been so important in terms of understanding our place in the solar system. As I mentioned, a sun-centered solar system. Our yardstick, a cosmic yardstick, one astronomical unit. It started our measuring system in space. And 50 years ago, this year, we launched our first space probe to Venus. So it was a planetary object of extreme importance that changed everything for NASA planetary science and really created solar system exploration as we know it today.
And tell us again, Jim, we've talked a little bit about the significance. Historically speaking, this is something, talk about Captain James Cook, for example, back in the, is it the 1760s, right?
Yes, indeed. In fact, these transits were gaining a lot of interest in Europe. And in fact, you couldn't always see it from Europe. Sometimes you had to travel to great distances. And a lot of these early countries actually funded expeditions. Several expeditions to Tahiti, for instance, like the Cook expedition, went down to observe the transit. And one of the reasons why they wanted to observe it is to look at the transit at two very distant locations on the Earth. And this would enable them, based on the timing of each of those observations and a little trigonometry, thanks to Sir Edmund Halley, to be able to calculate that 1 astronomical unit. So this was really the first time that countries were investing in science, in expeditions to be able to do really fabulous science and understand our solar system as we know it today.
Jim, we know you have to leave. You'll be back a little later.
That's good.
You've got an event, right?
Yeah, I've got to go to an event.
And it has something to do with this transit of Venus, is that right? You're going up there? You're going to actually go out and observe and chat about it?
Yeah, we're going to talk to a number of people that are on a roof.
Great.
Looking at it and enjoying that, and we're going to talk about the history, we're going to talk about the science, and we're going to talk about what transits also mean for other fields like astronomy and astrophysics. You know, we're using that same concept of transiting planets to find other solar systems around other stars in our galaxy. So it's a historic event on many levels.
I want to ask him, where can I get one of those buttons? What's that button say? I don't know if our audience can see that. That looks pretty cool.
Well, it is a great button, but you have to go out and observe the transit. It says, I observed the Venus transit. Of course, you'll have to wear it this way if you observe the 2004, and this way you can wear it when you observe the one tonight.
Okay.
Or late today in the D.C. area.
Well, Jim, we want you to have a great time. We'll see you a little bit later. In the meantime, we have somebody else standing by at the Johnson Space Center in Houston, Mario Runco, who's going to be with us shortly and talk a little bit more about this Venus transit and what it means historically, scientifically, and talking about history again. We have a little message.
Yep, and before we run the intro there, again, stay with us, ladies and gentlemen. Join the conversation on social media, Twitter, Facebook. And this is the first stop. We're going to be going all over the world. Let's go to Houston.
We are now on the eve of a second transit of a pair, after which there will be no other till the 21st century of our era has dawned upon the Earth and the June flowers are blooming in 2004. When the last transit season occurred, the intellectual world was awakening from the slumber of ages, and that wondrous scientific activity, which has led our present advanced knowledge, was just beginning. What will be the state of science when the next transit season arrives? God only knows.
Here at NASA headquarters in Washington, D.C. Al Feinberg, senior producer, NASA Television. My colleague, Dwayne Brown of the Office of Communications, Science Mission Director. And this historic event, not the next one, not for another 105 years.
I'll be around. Maybe? No, never mind.
Barring a miracle of science.
Well, I work for the Science Mission Director. We may have it. You never know.
You know the right people. We'd like to go now, and we've got people we're going to talk to all over the globe today. We're going to be talking to folks in Australia. Our NASA Edge colleagues will be at Mauna Kea in Hawaii. We've got hopefully we can hear from somebody in Fairbanks, Alaska, if he makes the call.
That would be pretty cool.
And some other folks too. But in the meantime, let's go to the Johnson Space Center, where standing by is former astronaut Mario Runco, who is considered to be one of the experts at regarding the Venus transit. Good afternoon. Good afternoon, sir. Welcome.
And thank you. Good afternoon to you. Thanks for having me.
Tell us what this means to you personally. This is a pretty exciting event.
Well, actually, for me, it's an exciting event that goes back of my interest in space and astronomy since I was a young boy. But more importantly, today is the involvement with the International Space Station and the observing of the transit by astronauts on board, particularly astronaut Don Pettit.
Now, we understand that Don we're during cruise sleep. So there's a possibility that we're not going to be able to see too many shots, is that right? But Don's going to be getting up periodically and taking some pictures and shipping them back down to Earth, is that right?
Well, that's correct. And Don, let me clarify the crew sleep part of that. Officially, it's during crew sleep, but I suspect this event to the crew, and particularly Don, is like Christmas Eve, and the presents are going to be under the tree, and you're not going to sleep very well. So Don is actually going to be getting up and taking pictures of the transit of Venus beginning in shortly here within the hour. And he is going to be taking the pictures using an 800mm lens with a high-end Nikon camera. Of course, he has the appropriate safety solar filter on the end of it and the prescribed sunglasses to do the filtering. He is, and it's a first for the International Space Station, going to remove an inner pane. It's a safety pane to protect the windows from being scratched and the like. They're actually called scratch panes, but those inner panes are not optical quality. So those are going to come off to allow us to get more detailed, sharper, clearer images of the transit. And as I understand it, as soon as Don is going to collect a battery of images, he will load them up for downlink, and we'll get those posted online as quickly as possible.
Well, sir, this is Dwayne Brown, and again, thanks for joining us. Let's bring it a little bit down to earth here. We've talked about all of the places all over the world that are going to be monitoring and observing. Can you tell us the scene down in Houston, Texas? Well, what's the folks looking at, and anything that really, are they excited down there as the whole world is? I'm quite sure, right?
Actually, very much so. It started off slowly, of course, as the transit got closer. The interest, of course, built over time, particularly once we found out that Don was going to be taking the images. Of course, that swept up most of the people here immediately at the Johnson Space Center, but in the wider community as well. And the historical perspective is quite interesting from my point of view, and I guess a variety of folks here, is that it pinpoints in time the technology we have today to observe the transit of Venus. You guys mentioned the Hubble Space Telescope. We have the SOHO satellite and others observing, and we have the International Space Station. Of course, we talked about James Cook, the English explorer that went to Tahiti to observe the transit of Venus. Like we are talking about him and previous observations, juxtaposed in time in 2012, people in the future will talk about what is now in orbit, the International Space Station, probably the personalities in Don Pettit and several of us, Dr. Green, et cetera. And then who knows, like you said, as in the future, what will hold in 2117 on the next transit as to what we will be using, what will be in orbit, what spacecraft we'll have. We may have even have people who have orbited Venus at that point in time.
This is Dwayne. Just a follow-up on that. Looking into the future and orbiting in Venus, exciting times for NASA with the recent success of SpaceX and things. And to put it in context, the synergy between science and human spaceflight. Describe that for us. I think the future is bright for both.
Absolutely, and I'll put that in a historical perspective, because years ago, folks used to be an aficionado, a fan of robotic missions or of exploration in that mode, and then there was the manned space program, and there were two separate camps. But I think today, nowadays, most people understand that the two are very synergistic. The robotics missions certainly can go farther afield a lot more quickly, because we don't have to worry about keeping people safe and alive for a two-way transit. Maybe one day they'll be one way. They'll just send them out, and they will establish colonies, and they won't return. But I think the real quest and what really makes the exploration exciting, that brings people in, is having people directly involved, and what the human brings to the table. For example, if we go to Mars, the aspect, and actually let me mention, the Mars Science Laboratory is going to arrive there this summer. It's a new robotic probe that's about the size of a Volkswagen Beetle.
the most capable exploration rover we've had to date. It is going to be there, but it is limited in its variety, and that's a limitation of our technology today and what it can do. It's very capable, more so than anything we've sent there in the past, but the real ingenuity, the thinking, the discovery, the creative aspect to know what's important, to know what to look for beyond the programming is where the human being comes in. And indeed, that happened in our lunar exploration when we brought back rocks from Apollo. There are certain ones that were noted to be different and picked up and brought back, and they taught us so much about the moon, the evolution of the solar system. And so I think it's really a win-win situation for both. We need the robotic probes, certainly to answer some of the preliminary scientific questions, but to solve the riddle, to find out if there's life, for example, to dig underneath the rock that can't be moved by the robot, you want the person there.
Well, Mario, thank you so much for joining us. We're going to be going to another guest in a few minutes, but we want to thank you very much, and we hope you enjoy this evening as much as we know we will. And please say hi to Don for us up in the station, and we'll look forward to seeing his imagery.
Thank you, sir.
Okay.
Thank you very much. Happy viewing.
Right. Thanks. Okay, Dwayne, this is going to be quite an evening.
Yeah, we just started, and there's more to come.
Yeah, absolutely. Right. We're going to go, I think Jason Townsend, our social media maven, has an image, is that right, Jason, that you have for us? Is that right?
I do. We've been beginning to get some good images in here from the Solar Dynamics Observatory. We just retweeted Camilla SDO, for those of you who follow her on Twitter. We put her out, and there's an image that's from the 211 wavelength from SDO, and it's been put out on the @NASA account. So if you're not following along, follow us on Twitter. We're at @NASA. We're getting ready to post it up onto Facebook and everything. But it's a beautiful shot with Venus just beginning to pop into the field of view here and begin its transit across the sun. So stick with us. Remember to follow along. If you're out on social media talking about this, make sure to use #Venus Transit. That's the hashtag for tonight, and join the conversation. Hop online. Thanks, guys.
All right. Thanks, Jason. And we'll get those imagery up for you as soon as possible so you can see it right here with us as well. We are going to be going to the Goddard Space Flight Center, where we're going to be chatting with another expert to talk about this Venus transit and what this means. And perhaps we can find out from Dr. Jim Garvin exactly why this happens like every 105 years.
Yeah, and you know, when Jim, you know, we got a lot of Jims. We got Jim Garvin, just have Jim Green. It's a popular name, but these guys are the best of the best. And you know, at the Goddard Space Flight Center in Greenbelt, Maryland, they're home to the Hubble Space Telescope. They're home to the James Webb Space Telescope, the next generation, as some folks call Hubble 2.0. And this is why we're so excited, not only to be a part of this, but the incredible things on the horizon for the National Aeronautics and Space Administration. And the Goddard Space Flight Center is playing an extremely vital part in making that happen, Al. But this is about Venus, and I don't know, we're here, we're going to be going around the world. We got our main man, Jason, doing social media. Are we missing anything here? I mean...
Well, I think we talked a little bit. And we can start showing perhaps a little bit of information about some of the other locales we'll be going to at some point. There you can see, guys, the folks at NASA Edge. We're going to be going to them at 6:03 Eastern, which is coming up in another, I guess, 13, 14 minutes. And they are going to get us into the ingress of Venus as it starts crossing the face of the sun. Now, some of the other locales. Let's go and show you. There they are. They're in Hawaii. There's the Hawaiian flag. Is that right? Wow. That is great. And here are some of the other locales. We've got the NASA Edge Hawaii, Mount Wilson Observatory in California, the Glenn Research Center in Cleveland, at Alice Springs, Northern Territory, Australia, which is right in the smack dab in the middle of the Down Under. And we've got the folks from the Coca-Cola Space Science Center at Columbus State University in Georgia. They're there. They actually, Dwayne, they also have a team in Mongolia, I believe. We'll also be there. We're going to have a web stream coming from Norway. And this one is one of my most
I was looking at. I was waiting for you to. How do you pronounce that?
I believe it's Muchul, the United Kingdom. That's in Lancashire, Great Britain, and that is where they're having a special web stream at the church, St. Michael's Church, where Jeremiah Horrocks was. He and his partner, I think it was Jeremiah Craven. Am I right? Who first observed the Venus transit. I think it was in 1631.
Yeah, well, we'll verify that.
Really,
but we got
cool.
all kinds of years and dates flying around.
Real cool. So, and Fairbanks, Alaska will be in Fairbanks. The Indian Astronomical Observatory in Hanley, India. And we're going to have a feed from the European Space Agency, ESA. They're going to have some information coming down from the Venus transit satellite that they have that is doing a polar orbit of Venus. And that's coming through Svalbard, Norway, I believe. That's where their space station is. And interesting thing about Svalbard, which I don't know if you're aware of this, but
you're just a man of knowledge. Just keep it coming, man. I'm learning a lot.
You can find out a lot on the internet.
Maybe we should go to some of these places.
Well, yeah,
you think we can?
I'd love to do that actually. But Svalbard is the place where the world sends its seeds to be stored in the event of some catastrophe, some world famine, so that everything is protected. There's a deep vault in this mountain, and because it's so cold, it forms another layer of protection. And it's the global seed center, seed storage center. So, and it's quite interesting, but that's also there. And then, of course, we've got the International Space Station.
Well, I guess it's safe to say, and we've been saying this at the beginning of the program, ladies and gentlemen, this is a global watch for the Venus transit. And my colleague here, Al, that's some of the places that we hope to bring some of the live coverage there, but there are places and viewing areas all over the world. In fact, Al, it's my understanding that there are stadiums that are going to be hosting thousands and thousands of people just for the viewing. Sports stadiums. Wow. I think that is very, very, very cool. It is global. Follow the conversation on social media, all of you, Facebook, Twitter, YouTube. Watch it. I know you're out there. We got our main man, Jason Townsend. We're going to have fun, and this is just the beginning. Keep staying with us. Al, hopefully we can get outside and even see this, but if not, I'm happy, and I can't wait for our next guest.
Well, in a few minutes, we're going to be starting the ingress, 6:03 Eastern Time, and then we'll be going to NASA Edge, and then maybe we can get outside because there's still some hours of light here, and hopefully there's no cloud cover. But now let's go over to our colleague, Dr. Jim Garvin, the chief scientist at the Goddard Space Flight Center, a great hockey fan as well. But Jim, tell us about tonight and why this is so exciting.
Well, hi, Alan, Dwayne. It's great to be here. Tonight's really special because this is a very rare astronomical event. And what we can learn from it is really a dry run for how we can observe like planets or Earth-sized planets transit other suns. So while this is an event here and now, also a proving ground for how we can discover extrasolar planets and even start to tell whether they're more like Venus or more like Earth. So for all of us interested in the solar system, we can actually think beyond into the larger universe from this event.
Now, for those of you not in the know, in the past several years, I guess, through one of the NASA missions, Kepler, there have been identified at least, 700 planets outside of our solar system called exosolar planets, and using the same phenomenon, a transit in front of a planet or in front of a star, similar to what Venus is doing in front of our star, the sun. Isn't that right, Jim?
That's right. And in fact, that's why this is so important. We're now, from a space-age perspective, a spaceborne perspective, seeing what we're trying to understand around other stars, and in fact trying to use Venus as a proving case to understand the difference between a big hot orange ball planet like Venus versus our pale blue dot Earth is one of the most important kind of things we can do. And as we look forward in exploring the universe, that's one of the things we want to be able to tell. The atmosphere of Venus is in a different state than that of our own planet, which of course is where we live and hospitable. So as important as this is right here in our solar system, it's also important as we look beyond. And it also reminds us, as we think about Venus on this historic date, how little we know of our sister planet. I mean, to me, that's one of the exciting things. We got to get there to understand this world.
Jim, this is Dwayne. Again, thanks for joining us. And, you know, and I told our audience at the top of the program, I have one of the coolest jobs working with incredible scientists as yourself. I'm going to divert a little bit because I know you're working on an incredible new strategy for Mars. And I know this is about Venus, but kind of put it in context about Mars, what's going on, and how perhaps Venus and Mars, I know you had mentioned Earth, how they may, well, how they certainly differ, but any similarities. But before you do that, tell us what's on the horizon for the new Mars planning program.
Well, first, Dwayne, what's most exciting in the near term for Mars is we're a month or two away from a historic landing of the first surface observatory of the class of in history called the Mars Science Lab. And I think the Mars Science Lab and that rover Curiosity, an investment in 10 years, 12 years of work by the Mars community, really puts into perspective. We've come out of the kindergarten age of exploring Mars into a much higher state. And the Mars Science Lab will be asking the kinds of questions that we ask even about places here on Earth, on another world, with a robotic laboratory, a robotic surface observatory. So as we plan the future of Mars, we're going to learn from the Mars Science Lab. And that's landing's coming up on August 5th and 6th here on Earth, another big solar system event in this year. And that landing will help us, and the science from that mission, help us to understand the kind of questions as we probe the world of Mars, compare it to Earth, the kind of questions that were left for the planet Venus. We've never done anything like the voyages of exploration we've done at Mars, as you know, Dwayne. The Mars exploration rovers, even going all the way back to the Viking mission, the Mariner 9, those missions at Mars have opened the Martian frontier. And now, as we watch this historic transit of Venus, we wonder about that Venus frontier. What could we find? I like to tell the kids, there's a pony out there, we just have to find it. So, but let me come back. Mars is in a very important state of changing knowledge. We know where we need to go. We know what we could possibly find. And so we're planning a big team across the country, across the world, a workshop in Houston in about 2 weeks, in fact, to bring together those ideas. We're planning what that future could be, responding to what the Mars Science Lab will tell us, and we can't really foresee that until she makes those measurements, but also responding to what we've learned for the last decade of the Mars exploration program. How do we explore a potentially habitable world? How do we find those fingerprints, those clues? It's kind of like CSI does Mars, to what might be preservation of past records of life, if there was ever any. How would we find extant life if it ever were to exist on Mars? These tough questions are part of the planning horizon we have, guided by the strong recommendations from the National Academy of Sciences, which has given us, if you will, a blueprint for planetary exploration for the next decade from what they call a decadal survey. So for Mars, lots coming, Mars Science Lab and MAVEN, the next two missions. And after that, an open frontier of possibilities. Of course, central to them is finding a way to bring back materials from Mars to our Earth labs so we can basically generate science that will be a gift that keeps on giving. Those samples, like we have from the moon, the ones we need from Mars will be that kind of legacy. Now, what that does for us, though, Dwayne and Al, is bring us back to Venus. So why aren't we there on Venus? With this great program of exploring Mars, heading out to Pluto, going back to Jupiter, exploring Saturn, what's wrong with Venus, you might ask, particularly on this moment of the transit as it's about to begin. And the problem is Venus, as one president once said, is really hard. And to get to Venus and do the kind of things we want to do, the kind of things we're doing on Mars, takes new technology, creativity, new classes of instruments, because the environment there at the surface is just so inhospitable. It's unimaginably different than Earth and Mars. So here we sit as we're about to explore Mars in the major next step, and we think back at our sister planet Venus and say, well, someday we got to get back there.
Jim, question. with this Venus transit, obviously there are expectations, scientific expectations, about some of the things we might learn. Can you prioritize for us maybe the top 3 things that you would like to see us learn from this Venus transit of 2012?
Well, I think Al, there's at least 3, and let me give them to you in sort of no absolute priority order, because it all depends on the scientist making the observations, how important they are, and it's always hard to judge our kids, if you will. The first thing we're going to be doing is using the Solar Dynamics Observatory. We will be, for the first time, having a high-resolution spaceborne view in sort of movie mode, of what's going on as Venus occults the sun tonight for the 6 to 7 hours that it will last. And by timing precisely the information we collect from the various imaging systems and imaging spectrometers on SDO, we can better quantify exactly where things are in its instrument's fields of view. And that kind of geometric improvement will be extremely important for calibrating those instruments to make even better measurements of the sun as part of the SDO mission. Number 2, we are going to try a very novel new kind of experiment, again, a practice for things we might be able to do as we look to other suns and planets around them, by using the Hubble Space Telescope in what is a very challenging kind of observation, but a very exciting one, to observe the faint variations in the change in light as Venus crosses the sun, as reflected on the surface of the moon. Now, we've looked at the moon with Hubble as an object of exploration in 2005 and before, but this will be different. We'll be watching the moon to see the effects of the transit of Venus on the sun, and try to see very, very faint, less than 1% changes in the reflectivity of the light on the moon from Venus on the sun, to understand some of the subtleties of the atmospheric chemistry of Venus. And Venus' atmosphere is like a giant chemistry lab of planetary evolution. It's so big, it's changed, we think, dramatically since the time the planet was born over 4.5 billion years ago. So it's a record book, and we want to measure its chemistry using every inventive technique we can. So the Hubble experiment is another one. Other satellites, RESI, and some of the satellites that are from ESA and Japan, will be making independent observations, all coordinated as a giant science network or family across the world. And so those together will try to peel back, try to extract, if you will, subtleties of the makeup of that atmosphere of Venus, which we just haven't gotten that far probing. We had limited success with our measurements thus far here in the United States, understanding this massive atmosphere of our nearest neighbor planet.
Jim, this is Dwayne. It's always a pleasure to have you a part of the shows like this. I've known you for a long time. Thank you for your time, and enjoy this evening. And we'll see you at Mars, and enjoy the show.
What you're seeing now is a live picture from Norway, one of the locations from that country. We believe this is Spitsbergen, also known as Svalbard. We're about almost 2 hours into the 6-hour and 40-minute long 2012 Venus transit. And again, this is from Norway. And hi, welcome again. Al Feinberg, senior producer here at NASA TV, with my colleague, Mr. Dwayne Brown from the Office of Communications, our lead Science Mission Directorate Public Affairs Officer. And we've got some really cool stuff to show you.
And Al, we want to tell our listeners, our viewers especially, that this hour, this section, and this segment will have some incredible images from an incredible spacecraft. In our first segment, we had Dr. Jim Green, who will join us again later in our show. But now we're going to talk about the images with one of the premier scientists that study the field of heliophysics, and you'll learn more about that. But I think we need to go to our social media guy, because he's been quite busy. And Jason Townsend, it's been some incredible stuff you've seen on there, am I correct?
Indeed. Hi, guys. How's everybody doing? This is the Venus Transit 2012. So if you're just joining us, we've managed to get out some awesome images from the Solar Dynamics Observatory. If you're following on Twitter, that's at @NASA_SDO. They've put up a variety of images that show the transit going on. If you're also following along on the conversation, make sure to be using the hashtag #VenusTransit. That works on Twitter, that works on Google+. Follow us at @NASA, follow us on Facebook, look for NASA, and also follow us on Google+ out there. If you're out there taking pictures, though, make sure you're doing it safely. But once you've taken those pictures, upload them to our Flickr gallery. That's available. If you look on Flickr, search for the group Venus Transit. So to take it away and explain some of these wonderful images here, we're going to turn it over to our special guest this episode.
But first, you pulled up a couple of images from SDO, Solar Dynamics Observatory, that just are fascinating. Can you get us into those, and then we'll have our guests talk about them?
Sure, definitely. So what we're looking at here is a couple of images that were tweeted out a little bit ago, and we posted them on Facebook and Google+ here. It starts with the Venus ingressing here. Moving on, we've got a much better high-definition shot from the Solar Dynamics Observatory here of Venus getting ready to enter into the sun for ingress. The following shot we've got is a really awesome image. Look at that. It's the sun. It's just incredible, and we've got Venus transiting right in front of it there. It's underway. This is from about an hour and a half ago, a little bit more than that. And then the last one is an incredible image here. This one shows Venus in the sun, close up, a little zoomed in there from the Solar Dynamics Observatory. And finally, the full disk. This is incredible, and we're going to have Lika here talk about this.
Yes, I think we need to, this special guest we have, I think she can really explain what we're seeing here. So I'll let you do the honors this time.
Lika Guhatakurta. Guhatakurta. I'm very sorry. We call her Lika G's to avoid things like that. But Lika is our lead scientist here at NASA for the Living with a Star program. And Living with a Star, of course, is the sun. And Lika, tell us about some of these images, and then we can talk a little bit more about the transit itself.
Well, let me tell you just a few words about Living with a Star. You're, of course, looking at the sun. And the sun is an ordinary magnetic variable star. But the fact that it's magnetically variable really produces this wind and storms. And our planet is embedded in the outer atmosphere of this planet. And so we feel the effect of Living with the Star. And that's the genesis of the program Living with the Star. But, well, I'll digress from that now. And what you're looking at here is Helium 304 image. Now, of course, it's kind of complicated, right? It's a line that helium produces, and it's 304 angstrom, 10 to the power minus 8 centimeters. And none of this make any sense.
Yes, but for dummies like us, please explain.
I understand a little bit of this.
And so what you're seeing is a full disk image of the sun, and this is a very special observatory, Solar Dynamics Observatory. It takes images that are about 10 times better than the high-definition TV. It's actually taking images at a temporal cadence of every 10 seconds. This is something we have never had before, and it's doing it at 10 different temperatures. So the temperature scale, if I was to convert this image, it would be about 50,000 degrees Kelvin, or maybe 90,000 degrees Fahrenheit, something like that, in terms of Fahrenheit. And you're seeing Venus in kind of really exquisite detail because of the spatial resolution.
Now, how about this next image we have here?
And so that particular image is in a wavelength band that's, instead of 304, is 193. But let me convert it into a temperature scale. And in terms of temperature scale, this is of the order of 1.5 to 2 million degrees Kelvin. This is the temperature of the corona. And this is kind of a mystery, if I may add. I mean, you might ask the question, why do you look at the sun at all? If you look at the sun with unaided eyes, you see this yellow ball. That's about 5,000 degrees Kelvin temperature. But if you actually look at the corona, which is outside the sun, it's like you are, if you're near the stove and you're moving away from the stove, you think that the temperature would go down. Well, in this case, what happens is that the temperature goes up. So that temperature is in millions of degree Kelvin. And that's kind of a mystery.
Lika, I know we're going to talk some more and ask you a question about some of the images. But let me take a step back for our audience, because astrophysicists, you have planetary scientists, but heliophysics, explain to the audience, what is heliophysics?
Oh, we have so much fun with heliophysics. Heliophysics wasn't even a word up until maybe 5-10 years ago. So remember, scientists came up with this word, right? And so you can define it. So we have given a meaning to this new discipline that we call heliophysics. Heliophysics is something like an environmental science with astrophysics, really. So you're studying the sun as an astrophysical entity, but you're studying its impact not only on our planet, but all other planetary environment. So you are actually studying sort of the sun, the heliosphere that the sun dominates with its magnetic field, and all the interaction that takes place with this magnetic field and all planetary environment. But of course, to us, what's most significant and important is that we understand the connection between sun and earth in great detail, and that's the study of heliophysics.
Now these great pictures, we're going to go to another one now. Can we go to this next one? There. Besides giving us wonderful pictures of Venus transiting the sun, STL also obviously tells us a lot about the sun and, as you said, its effect on the solar system, but also the impact of what happens on the sun on the Earth, and especially in the new, regime of solar weather, if you will, right?
That's right.
Something that's more and more in the new space weather.
Yes, yes.
Explain to us, please.
So, heliophysics, we sometimes say, is the science of space weather. So space weather is, again, one of those new words. We understand terrestrial weather. It's meteorology, it involves pressure, temperature, water vapor, gravity, etc. What space weather is really what happens on the sun, and these are, so sun produces particles and sun produces radiation. And and sun produces storms. So we get sometimes these dark regions on the sun, and in probably, some of your images, when you bring up the full sun, you'll see these dark blobs called sunspots. They are region of intense magnetic field. And when you have intense magnetic field, this magnetic field can actually rupture. Kind of like, if you think of rubber band and you twist it and twist it and twist it, the tension gives and it just breaks. So magnetic field lines are kind of like that. And so, underneath this dark sunspot, you have magnetic field that are just boiling. And then they can rupture and produce coronal mass ejection, solar flares, etc. So tremendous amount of energy and particles are then thrown out in the form of cloud that goes through the interplanetary medium 93 million miles. It's a huge distance. It takes light about 8 minutes, but these particles travel between about 400 to 1,000 kilometers per second. So it takes them a few days. When they arrive at Earth, these particles push on the magnetosphere. This is Earth's own shield, essentially, that protects us from these particles. And every once in a while, the orientation of the particles, the magnetic field of the particles that come from the sun, the solar wind, matches up, syncs up with Earth's magnetic field. Then these particles can penetrate into Earth's geospace. The first sign of a geomagnetic storm is that we have an aurora, beautiful aurora, and then any number of other disruptive phenomena can happen.
We're going to go now to one of your colleagues down at the Marshall Space Flight Center, Mitzi Adams, who I know is a colleague and friend of yours. Mitzi, how are things looking down there at Marshall? What's the weather like, the cloud cover?
Well, earlier in the day, we had clouds. And we were really worried that we weren't going to be able to see the beginning of the transit. But things cleared out, and it's looking much better now.
That's great. Now, have you been scanning, like we have, all the different websites around the world to see what's cooking there, if you will?
A little bit. I was involved in answering some questions on the live chat. I had my number 14 Welders glass, and I went outside and looked at the beginning of the transit. I also looked at a feed from Hawaii and from our own telescopes here in Huntsville.
We're going to go now, Mitzi and Lika and Dwayne, to another website that we've been talking about or teased before but haven't actually gone to, is in the UK, in Lancashire, Muchul, which is the home of Jeremiah Horrocks, who in 1639 was the first person to actually observe the transit and document it. And this is St. Michael's Church. Can we go back to that for a second? St. Michael's Church, where Jeremiah Horrocks was a curate. And they have the stained glass window there, as a matter of fact, in his honor. But they're having their own presentation there, too. But Mitzi, can you tell us a little bit more about what impressions you've had so far and what you've been looking for in this transit?
I think most of my impressions of this transit have had to do with education and exciting the public about viewing the sky in general. And it's also interesting that at the time Horrocks made his observation, there was only one or two people who saw it. He may have been the only one. And the next time there was a transit, you had a few more people observing it. And the next time you had hundreds of people observing it. And then our transit in 2004, we had millions of people observing it. And today, we have even more. So just in a few hundred years, we've had this change in the way that we've been able to observe the sky.
Well, let's see. Lika, I have a question for you. You explained the area heliophysics. Now, your fellow colleagues out there and scientists that are looking at what can we expect that you guys will take away from this? I mean, it won't happen again for another 105 years, but what type of data? Why should people, and we asked Dr. Jim Green this, but what is the why we should care factor? Not just for the general public who know, little kids know what the sun is, but for the scientific. So why we should care from a public view, and certainly why the scientific significance of this.
Oh, I mean, Mitzi talked about the public view, I mean, how we people are curious beings, and forever we have, looked at the sky, and astronomy has had impact in every culture. But the reason we study this from the scientific point of view is really to understand the sun as a star, the Venus as a planet, the connection between Venus and the sun. And so what we hope to do, with SDO, I mean, it's a great opportunity. Solar Dynamics Observatory was really meant to study the sun. But now that this opportunity has presented itself, what we are going to have are actually observations in these various temperature bands that you're looking at. What's going to happen is we're going to get data that's going to, Venus has an atmosphere, as we know. I mean, even though it is the planet of, goddess of love, it's a hellish planet too. We know that. We couldn't survive there. So it's got a thick atmosphere. And these wavelength observations are going to give us a clue about the content of oxygen. So Venus' atmosphere is largely carbon dioxide and nitrogen. Very little nitrogen, pretty much all carbon dioxide, which gets dissociated into carbon monoxide, CO, and oxygen. And so when you have these soft X-rays go through this, we are going to be able to detangle actually the composition and how much oxygen is there.
Fantastic.
Isn't that fascinating?
That's very cool. And I think we're going to swing back
Yeah,
to...
let's go back to Mitzi down at Marshall. Mitzi, what are you hoping to learn yourself? And as you look at these images from SDO, they're pretty striking, at least to the untrained observer like myself. They're cool. The wow factor is there. How about for you? What do you take away from those?
I agree with you. The wow factor is definitely there. I'm actually doing research with SDO data, and every day when I look at the images, I'm just truly amazed at what we've been able to do here. In terms of the transit itself, I personally won't be doing any research with these data, but I think that scientists will be able to use the data to fine-tune some of the techniques for looking for planets outside our solar system. Kepler and Hubble are both going to be doing that sort of study. And the Heliophysics mission will also be using the transit of Venus to fine-tune some of the instruments on board that spacecraft. So I think there are a lot of good scientific reasons for using this opportunity that has presented itself to make great strides in our science.
Mitzi, this is Dwayne. We've been going around the world, and Al's going to take us to another country, and I know Lika is going to be very familiar with. But just a quick question. We've been seeing a lot of excitement and events all around the nation. And what's happening down in the Huntsville, Alabama area? Just sort of give us a description of the excitement there and what's going on in the city. Can you do that for us?
I certainly can. The Space and Rocket Center here is having a viewing opportunity with telescopes supplied by the Von Braun Astronomical Society, and there are other viewing events going on in the area. In Decatur, which is a city to the west of Huntsville, there is an observing opportunity at one of the local elementary schools. And actually here on base at Marshall, some of our astronomers have telescopes out looking at the event.
And speaking of telescopes out, we're going to go to a shot right now from Hanle Ladakh in India. It's the Indian Astronomical Observatory. It's the world's highest station, webcasting the transit of Venus at 14,800 feet. And Lika, you're familiar with this place?
Well, I know it exists. I haven't had the good fortune to visit the place. That's where I'd like to be, if I could. Not quite yet, but when they...
Tell us about some of the are you familiar with the capabilities that they have there?
Not in great details, but I know it's a very advanced telescope and very high up, so the clarity of the sky is exquisite. And I know that they have data connections directly to Bangalore. So, scientists in Bangalore can actually use the data. You don't have to be stationed there at the observatory.
I guess this is early morning, so they're just waking up to this. So this is probably pretty cool for them. Which brings to mind a question. Scientists from all over the world are studying this. Is there some sort of one-stop shop for scientists where all the data gets collected and shared for something like the Venus transit, where scientists from different nations can go and find out what another has discovered?
Compare notes and things like that.
Right.
Scientists will, of course, do this. Scientists love to organize meetings, and I am sure there'll be few 2012, Transit of Venus conferences. That's where, such data gets validated, peer-reviewed. When you present, there'll be some new findings. Every other transit that we have seen so far, there's always been some something new. The last 2004, when we were looking that with our new TRACE observatory, we found this arc, and we didn't know what it was. Scientists studied it and figured out what the arc was all about. Before that, it was this, dark sort of raindrop-shaped structure, which is a telescope effect. So I'm sure this time around also there'll be new findings. I don't even doubt that.
Mitzi, for you down in Huntsville, do you have any ideas or any suspicions, if you will, about what we might learn this time around?
Any suspicions?
Perhaps that's not the best
It's
word.
always hard to predict because things happen serendipitously. So I really can't say.
One of the things that we hear here at NASA a lot of times about exploration is that we don't know what we don't know till we know it. And we'll find out things in science as we do in any form of exploration of space that we will learn something. We're just not sure what it'll be
That's true. I mean, there are things, like known unknowns. So in case of SDO, we want to know something about our instrument. Okay, so we are going after that because Venus provides that very dark space. We are going to get a point spread function, leakage of light from one pixel to the next, and that's very important to, get a good reading of our data. The position of the transit is actually going to give us a very good sense of the orientation north-south of the actual solar images, because when you launch an instrument in space, what happens is sometimes, due to vibration and all that, things shift, and so you can't be absolutely sure about the accuracy of your pointing. So these are opportunities. So those are the known unknowns that we are going to fix, and then there are the unknown unknowns, which are the new findings, which as I said, do not even doubt will be coming out, but we don't know what they are, as Mitzi said.
Well, Lika, before we go to our social media guru, we have a lot of young folks watching this broadcast. So we're going to go to social media and then we're going to come back. But I want you to you've explained heliophysics and the scientists. You're a role model. I've seen you inspire, young women, young folks. So maybe take a few moments to just tell the folks if they're interested in studying the sun and going in this field, some guidance and recommendations. So think about that. But we're gonna visit Jason Townsend. There's a lot of activity on the social media site. Jason, give us an update. What's going on over there?
Sure. So we're trending out there. If you're following along and joining us in the conversation, make sure to be using #PoundVenusTransit. You can use that on Google+. You can use that on Twitter. We're also on Facebook. You can look for NASA and follow along. We've been putting up some good images that are out there. We are making sure that we're getting the latest and greatest from things like the Solar Dynamics Observatory. So if you're following along, make sure to follow @NASA on Twitter. And if you're taking photos of yourself, of your own viewing out there all over the globe, make sure to upload your photos to Flickr. If you go onto Flickr, make sure to search for the group Venus Transit and add them to the community pool that's out there. So thanks a lot for following along on social media, and keep watching. We got several more hours of this. So.
Thanks, Jason. Okay, so Lika, go ahead and inspire the folks that you do every day, these young folks who are watching this.
Oh, I don't need to inspire them. Venus Transit is inspiring people all over the world anyway.
That's correct, yes.
We are fascinated by anything heavenly. I mean, yes, we get a little tired of the sun because we see this yellow ball day in, day out. We get a little tired even of the moon, beautiful moon. But then you have a planet, go in front. I mean, how often does that happen? It is just mind-boggling that we can predict it. These are the things. So 200 years ago, we could have predicted it, and today we are doing it with greater accuracy. Today we have spaceborne observatories that are tracking it, and we are learning more detail about Venus. I mean, I don't think I have to inspire them. The story inspires people by itself. It's just awesome.
Yes, and let me ask this then. Let me ask this way. Heliophysics, if you want to go into that, what recommendations for the young folks out there? They're saying, wow, I didn't know that this type of field.
Heliophysics is here to stay. Kids, heliophysics is the science of space weather. And if there is one thing that's not going to go away, is sun's effect on our technology. Our technology, any machinery, is vulnerable to the electromagnetic radiation from the sun. And that can cause so many effects that I don't even want to go into, from little ones to really huge disruption of power grid to satellite failures. So it's a vast unknown field waiting to be explored. What's really interesting about heliophysics is, if we talk about astrophysics, it's really gravity dominated. If you talk about meteorology, it's gravity and pressure and temperature dominated. Heliophysics is the science that is magnetically dominated, and magnetism is something we don't understand very well. Magnetic reconnection, a fundamental universal process that ignites all kinds of energy that has manifestation in so many ways. So I find that to be a very exciting field.
Lika, we're going to go down to Mitzi again for one last question. Mitzi, the next Venus transit is not going to happen for another 105 years. We know, looking back, how people have waxed poetic in the past, historically, and they look ahead and they conjecture about what it would be like when the next one comes. Do you have any thoughts about what the folks in 105 years here on Earth can expect to know, or maybe to learn?
In 2117, what to expect? I don't know. If we think back to the last Venus transit and the numbers of people who were able to observe it and the way they observed it, it's very different from the way that we observe it today. And so possibly in 2117, folks will be able to observe it from space. So it could actually be possible to make your own Venus transit by positioning your spacecraft in such a way that you could see Venus transiting across the sun almost at will. That might be another a way that it would be very different. And scientists could study transits in that way as well.
Mm-hmm.
I'm glad you bring that up, Mitzi. In fact, when we launched Stereo, we actually worked on the Stereo spacecraft so that we would have the opportunity to see transit of moon as seen from the Stereo spacecraft. And that looks like an alien object, because the moon is about 4 times the size of the real moon. So you're seeing this dark ball. It seems like a different solar system. But I want to comment about, if I could actually dream 105 years, 117 years from now, I wouldn't think about the transit of Venus. What do you think about transit of Earth as seen from Mars?
Ooh, like that. Nice.
Nice, Lika.
Lika Kohata-Kurta, thank you so much for being here with us. Dwayne, we're going to be back at 10 o'clock.
And with the one and only Jim Green
will be back then and joining us, and head of our planetary division here at NASA. Thanks to Mitzi down in Marshall Space Flight Center. Mitzi, Adam, thanks so much. We really appreciate you joining us, and enjoy the rest of the evening down there. And now we're going to go to a live picture from IAO, the Indian Astronomical Observatory in Ladakh, India, and then we'll go back to NASA Edge, and they'll get us through till 10 o'clock, and we'll see you then.
Right, India, and thank you again, Lika, for joining us.
The fateful moment was now approaching. Enthusiasm, in some cases, rising to frenzy, was manifested by the crowd surrounding the telescope. Still, To have seen even a part of a transit of Venus is an event to remember for a lifetime, and we felt more delight than can easily be expressed at even this slight gleam of success.
Welcome back to NASA headquarters in Washington, D.C. What you're looking at is a live web stream from Norway of the Venus transit, the 2012 Venus transit, as it nears its completion. Back here live with myself, Al Feinberg, senior producer at NASA Television, my colleague, Dwayne Brown, Office of Communications, and the head of our planetary division at NASA Science, Dr. Jim Green. First, we're going to, before we talk a little bit more about the conclusion that's about to occur, we're going to turn it over to Jason Townsend, our media maven, social media maven, who has some really cool stuff to show us. Jason?
Yeah, hi. Thanks, Al. We're still plugging along here, putting up a lot of new images and things like that. We've got a couple of new ones up right now from the Solar Dynamics Observatory. So we're going to start with a full disk image here. This you can see is the full picture of the sun. In a second here, we're going to see if we have the full picture. Here we go, and we've got a wonderful picture with Venus up in the upper right-hand corner. If you zoom in a little bit on the next shot here, you can see it up close. It's a beauty shot there. This is the Venus transit going on. This is past the halfway point. And then if we go to the next one, you can see it in a slightly different band. You can see there's the sun again and everything, looking really good. And also, if you're following at @astro_pettit on Twitter, he's been doing a lot of photography up on the International Space Station. So here's one of his images that he had. But if you look on Flickr and you follow the JSC photo stream on there, or you track it on @NASA, or you track it on NASA Google+, or you track it on NASA Facebook, we've put up a link to all of the ISS pictures, and there's over 900 of them.
Wow.
So at this point, from the space station. Remember to continue joining the conversation using the hashtag #VenusTransit, and to follow along on @NASA on Twitter, NASA on Facebook, and Google+. And if you are taking photos out there, make sure that you're doing it safely. But if you are, make sure to upload them to our Flickr gallery. We've got a Flickr group going. If you look on Flickr, you can look for Venus Transit. That's the group to look for, and upload your own photos. We've also heard that we've had over 200,000 continuous simultaneous viewers on our webcasts online on nasa.gov and on venustransit.nasa.gov. So it's been incredible. Thank you all for joining us throughout the evening. We're going to keep manning the social media here all the way through the end of the event, and we're going to have some amazing time-lapse videos here at the end with the entire full transit going on. So thank you guys very much for joining us, and continue joining the conversation using that hashtag #VenusTransit.
Jason, thanks so much. And we might add that that 200,000 estimate is very conservative. So we like that. And in case you missed it, Don Pettit sending down those imagery. He is supposed to be sleeping right now. Of course, he is not. He is geeked out about this. And we thank him so much for giving us perspective that nobody else on this planet has. And now we'd like to take you to a tape presentation that came from the Jet Propulsion Lab out in Pasadena, California, and our colleague Gay Hill, who has something really fun to show us. Gay?
Hi, I'm Gay Hill at NASA's Jet Propulsion Laboratory in Pasadena, California, and right now I'm standing in a place called Cardiac Hill. It is a parking lot overlooking the lab you see behind me here. And if you look over here, you'll see that about a half dozen of our JPLers have brought in their own personal telescopes equipped with solar filters so they can share this once-in-a-lifetime event with some of their coworkers and also people who live in the neighborhood. About 200 people have taken us up on this offer. They brought in their kids, and they also got a lesson just a short time ago from one of our scientists, Art Chmielewski, teaching them exactly what happens during a Venus transit. And they got a free demonstration too. Take a look.
First, I'm going to show you why we're here today. What is Venus transit? So we're looking here, we start seeing Venus, and now Venus is going across the sun.
There we go.
And keeps on going, and we're going to be watching it. Okay? It's going to take about 5-6 hours to go all the way across the sun. She was very quick.
So you guys, what did you think?
I thought it was cool.
I thought it was honestly cool.
What did it look like?
It just looked like a big ball, like a marble with a tiny little pinhead on it.
At first I didn't know what it was, but then I looked closer and it looked like Venus.
I saw the sun, but I saw this tiny black dot, but I couldn't say it at first, but then I looked closer, and then I saw the tiny black dot, and I knew that was Venus.
It was different because if you usually look in the sun, you get like blinded, but today we could actually see it.
What surprised me about it most was the fact that I guess that I was able to see it in my lifetime.
What are you going to do, tell your grandkids about this?
Assuming I have any.
I feel very lucky that I get to see it when I'm at such a low age because I get to learn a lot. It's really cool. You can see it through, and if you can look closely, there's like a really, really extremely tiny black dot, which is Venus.
If you missed this one, that's okay. There's another one coming. Unfortunately, it's 105 years away. So you can understand why these kids are stoked that they just witnessed something that happens just once in a lifetime. I'm Gay Hill from NASA's Jet Propulsion Laboratory.
All right, Gay, thanks so much. Great job there. Lots of fun events like that going on all over the world, and of course at the different NASA centers. And I'm going to guess that young man's going to have grandkids just so he could tell them that he saw that. Gentlemen, we're almost near the end here. We've got one more place to go before we wrap things up here. We're going to go to Muchhool, Lancashire, England, and the UK, and this is where Jeremiah Horrocks, who is the gentleman in 1639 who first observed the transit of Venus with, I believe it was Jeremiah Craven. This is the church where he was a curate, and there was a stained glass window of him there in his honor and memory, and they're having a great ceremony there and a service following the events of the day, and just a cool shot. So, gentlemen, where do we stand?
It's been fun. Let me give a few shout outs to the centers and to NASA TV and to the web and all of the folks that made this happen. But there's a special person that I definitely have to give a shout out to, and that's Kristen Erickson. She is the director of the Planetary Strategic Communications and really was vital to making all of this happen. So Kristen Erickson, thank you. We all thank you. The world thanks you. Great job as always. And obviously the reason why we're here is because of you and all of the work and the teamwork was going on. Folks, we're wrapping up here. We've had fun. Thanks for hanging out with us, all the social media. But we're going to turn to Jim Green, Jim, thank you again for being with us for this entire time. Let's sort of wrap this up and put this in context. We've talked about Venus. We've had heliophysicists come here. But this is the year of the solar system.
Yes, it is.
You've been pretty busy.
We have.
Kristen, and all of your engineers and scientists. Tell us about the year of the solar system, and there's something special happening in August.
That's right. The year of the solar system started actually about 600 days ago. You see, it's a Mars year. And that's 670 days long, or 77 days long. And during that time period, we flew by 2 comets, and we inserted in orbit 3 spacecraft, Messenger around Mercury, Dawn around a fabulous asteroid called Vesta, and 2 other spacecraft, Grail A and B, which we now call Ebb and Flow, around the moon. Very successful. And then we also launched a spacecraft called Juno to Jupiter, and the Mars Science Laboratory was launched in November of last year to Mars. And that's the next major event in planetary science, and that is the landing of the Curiosity rover on Mars. And that will happen on the East Coast in August the 6th at 1 in the morning. If you're on the West Coast, it'll be about 10 o'clock in the evening on August the 5th. And this is a fabulous rover. It's about a 1-ton vehicle. It's the most complicated and sophisticated spacecraft we've ever built. And it's going to go back in time, and it's going to look at Mars in its past and whether it could have been habitable. in a time period where there was plenty of water and other elements on Mars. And now back to the transit. What we're looking at is the fourth contact. This is the last contact. It's goodbye to Venus. You know, I actually started out earlier today saying that Venus is a real gift, and it really has been. It's enabled us, this is live from Hawaii, it's really enabled us to change our view of the solar system, calculate what an astronomical unit is away. We've used that yardstick throughout our solar system. It's enabled us to realize the sun was the center of the solar system and all our planets went around the sun. That changed our culture. Okay, here's another live shot. Another beautiful shot. You can see it's from Norway. Now back to Hawaii. So Venus is back now on its way, making its journey around the sun. And it'll be a while, as we said, another 105.5 years between this one and the next one. Back to Norway, and now we're seeing it leave Norway. Okay, so we saw it. Yeah, we saw it live from Hawaii, and it left. We've lost that contact. But here in Norway, what we do, just barely there. And what we do from Norway, which is, you know, quite a different latitude, quite a different viewing perspective, we still see it sitting on the disk just a little bit.
And it'll be there for a few more minutes.
Yeah, just about. It'll probably be about a 5-minute difference there, maybe a little less, but on that order.
Yeah. So Jim, let's get back to and you know we're saying goodbye to Venus, or the sun's saying goodbye, and you were talking about Mars and curiosity and exciting things with the year of the solar system. Continue with that.
Well, the year of the solar system, as I said, is just made up of a series of fabulous events. And these are mission milestones, but what the scientists really want is the data back from those encounters and orbit insertions, and the data's been flowing in like crazy. And it's going to enable us to make all kinds of new discoveries, and some of those have been started to coming out already.
Yeah, great. Well,
I think we're about ready to say goodbye, but we've got a couple, we have another treat. And Jim, you can give us the background of this.
All right, let me give you the background of this.
This is a song that's been missing for, what, 100 years?
About that. In 1882, many more people saw Venus transit than ever before, and it really got quite a bit of notoriety. And the top songwriter, the Will.I.Am of that day, was John Philip Sousa, and he developed this song. It's called the Venus Transit March, and he developed it for a dedication of a statue of Joseph Henry that sits right in front of the castle on the wall. Now, Joseph Henry was our first scientist of the nation, and he led the Smithsonian, which we now have the Air and Space Museum and quite a wonderful set of museums associated with that great group.
So that's what we're going to go out with.
That's what we'll hear with.
Well, I want to thank Jim Green. I would like to say we'll see you for the next Venus transit, but I probably would not be around for that. I want to thank everyone watching us. Jason Townsend, you rock, man. All you folks out there. It's been great with my colleague Al. Take it away, my friend.
Well, and a couple other folks, our executive producer, Fred Brown, and Anthony Stewart, Tony Stewart, not the race car driver, but our Tony Stewart, who is put it all together, and our crew, Shiva, and Eric, and Cliff, and everybody else, John and Vess, everybody in SED and Master Control, everybody's really worked hard. We've been here a long time, and it's been a lot of fun. So let's say goodbye. Thanks again, Jim, and everybody else.
My pleasure. My pleasure.
Yeah. Enjoy the music, ladies and gentlemen. Enjoy the images, and always remember, science never sleeps.
We may, but...
kleiner schwarzer Punkt hat heute in den frühen Morgenstunden für viel Furore gesorgt. Tausende Menschen blickten weltweit in den Himmel, als die Venus an der Sonne vorbeizog. Ausgerechnet in Deutschland machte das Wetter aber vielen Astrofans einen Strich durch die Rechnung.
Gerade rechtzeitig verzogen sich die Wolken gegen Mitternacht im australischen Melbourne. Und dann war der Blick frei auf die Sonne mit dem kleinen schwarzen Punkt am Rand. Das ist die Venus. Tausende Menschen haben am Morgen mit Schutzbrillen beobachtet, wie der Planet Venus im Schneckentempo an der Sonne vorbeizieht. Venus ist genauso groß wie unsere Erde und wenn man sieht, wie mini klein sie vor der Sonne ist, beeindruckend. Cool, wenn man sieht, wie winzig wir sind. Allein diese Erkenntnis zeigt, dass es noch viele Geheimnisse im Weltall zu lüften gilt. Etwa die Frage, ob es im Universum Planeten gibt, die so sind wie unsere Erde.
Wir sind uns fast sicher, dass es kompakte erdähnliche Planeten in Hülle und Fülle gibt. Die Frage ist, wie sehr sie der Erde ähneln. Es ist immer noch nicht ganz klar, ob die Erde einmalig ist.
Auf den meisten der bisher entdeckten Planeten ist ein Leben, wie wir es kennen, nicht möglich. Mit Hilfe von modernsten Hochleistungsteleskopen wollen Wissenschaftler in den kommenden Jahren aber ganz neue Erden entdecken und damit auch die Frage beantworten, ob es irgendwo im Universum fremdes Leben gibt.
Kommen wir noch einmal zurück zu dem Naturspektakel von heute Morgen. Moritz Wedel, was passiert genau bei einem solchen Venustransit?
Ja, zum einen passiert, dass die Wissenschaftscommunity natürlich in heller Aufregung ist. Es war nämlich ein großes Ereignis und dieser Venustransit, er spielt auch eine wichtige Rolle in der Wissenschaftsgeschichte, denn James Cook hat 1769 mit diesem Schauspiel den Abstand zwischen Erde und Sonne ausrechnen können. Ja, und was ist jetzt genau passiert? Die Venus schob sich zwischen Erde und Sonne, so wie es bei der Sonnenfinsternis der Mond macht. Und weil der Mond näher an der Sonne ist, näher an der Erde ist, verdeckt er die Sonne stärker. Die Venus ist weiter weg und deshalb sahen wir und die Wissenschaftler nur einen kleinen Punkt auf der Sonne. Die Venus hat die Sonne ungefähr 1/1000 verdeckt, also 1/1000 Stück der Sonne verdeckt. Am 8. Dezember 2125 können wir das Spektakel dann theoretisch nochmal sehen.
Watching a pretty rare event, the planet Venus in perfect alignment with the Earth and the Sun. Our science correspondent Palap Ghosh has been doing his best to peer through clouds in the UK at the site, trying to follow what the scientists call the transit of Venus.
A sight seen across the world. The black dot is the planet Venus. It's the size of the Earth, yet it looks tiny as it crosses the surface of the Sun. The transit began late last night. Visible first in North America, also in East Asia. And here were scenes from Australia.
These only occur 4 times every 243 years. If you look at it, I suppose, very objectively, it is just a little black spot on the sun. Some would say that a brand new Lamborghini is far more beautiful to look at, but they're common compared to this.
In the UK, amateur astronomers here at Bayford Bury Observatory in Hertfordshire had to get up early for sunrise to catch the tail end of the transit. We're now 5 hours into the transit and we ought to be seeing the last few moments of this spectacular event as the small dot of Venus exits the sun's surface. But instead, we're seeing this. Cloudy skies.
Bit disappointing from where we were, I have to say. Palap Ghosh reporting.
And starting at sunset on Tuesday in the eastern U.S., the so-called transit of Venus lasted 6.5 hours, and it was visible from every continent. Now, Venus appears as a small black dot moving across the solar surface. It's basically an eclipse, requiring a close alignment of the Sun, Venus, and Earth. And if you missed it this time, you probably won't get another chance. It will be another lifetime before Venus marches across the sun's face again. And that will happen in 2117. That's 105 years from now. Now, you may be thinking, a dot on the sun, what's the big deal? Well, actually quite a lot. Now, since the telescope was invented, 8 transits of Venus have been observed from 1631 to this year. Now, the transits in the late 18th century allowed astronomers to calculate the distance between the Earth and the Sun and how big the solar system is. Now, the 1769 phenomenon, it took place during James Cook's voyage of discovery to Australia, And he sketched the celestial event as it happened and as it appeared from Tahiti in the South Pacific. The British explorer then went on to chart the east coast of Australia. And the transit of Venus, it still has scientific value today. Astronomers are using the transit to test the way they search for planets outside our solar system. So that little dot in the sun helped unlock the universe. Let's talk more about the event with our stargazer and weather watcher, Mari Ramos. She joins us from the World Weather Center. Mari.
Hey, you know what? I was definitely both yesterday because, like you said, this was an event that was going to be viewed or could have been viewed across every single continent. There's some parts of South America and parts of Africa along the Atlantic would not be able to see it, but of course it would depend on the weather. And even here in the southeastern U.S. and here in Atlanta, we were kind of holding our breath because we were hoping to see it, but it was so cloudy. It was terrible, the weather yesterday, and then all of a sudden, forecast came true and the skies did clear up, and I got a chance to see it. So let's go ahead and roll the pictures of the Mari Ramos family album. This is my daughter, Emma. She got to see it too. She's looking through one of the telescopes. We went to a place called the Telus Science Museum up in North Georgia. And it was great because they had all these telescopes set up, these solar telescopes specially retrofitted to safely be able to view the sun. That's me. My older daughter, Michelle, took that picture there, and I'm looking through one of the telescopes. There were several dozen of them there, and it was actually very good, a very nice crowd that showed up. That's my daughter, Michelle, looking through binoculars, also specially retrofitted to be able to look at the sun. So it was quite a spectacle. There were parties like this all across the world, really, where people were getting together to view the sun. And you know what? I have one more picture to show you, Christy. This is pretty cool. You may have seen this one on Twitter. It looks like all the other ones, right? Well, my daughter Michelle took this one with an iPhone through one of those telescopes. So I thought that was pretty good. You know, there you see the transit of Venus with our little family album there. So if you guys got to see it, send us our pictures. Send us your pictures to ireport.com. So one of the places where people were hoping they would be able to see it was across Asia. Guess what? A lot of rain in some cases. And I want to talk to you a little bit about the monsoon now because it finally started. We didn't get to talk about this yesterday, Christy. On Tuesday, officially declared that the monsoon began in Kerala in the southern tip of India. This is the latest start of the monsoon since 2005, but we'll see it continuing to advance, we think, over the next few days. The official place where the monsoon is now continuing to advance here across the south and also across other places here in the Bay of Bengal. That white line that you see there, that progression of the monsoon expected to continue moving up through July 1st. That's helped a little bit with as far as the temperatures in the south, but still very, very hot as we head to places farther to the north. Now, other places that we've been looking at as far as weather and rain has been across Southeast Asia, very heavy rainfall across those areas there. We haven't had any rain in Beijing, and we really need to get some rain in those areas. Look at what the air looked like. It was kind of difficult to see. Again, a very smoggy day across Beijing. The last time it rained, Christy, was about, 3-4 days ago, and they only had 1 millimeter of rain. With all of the industry and all of the people and, of course, the geographic location, air quality can get very bad during the summer months, and that has long-term effects. You know what it looks like there. But when you talk about bad air quality, not in Beijing, not just in Beijing, but in other parts of the world, there's short and long-term health effects that happen, and that's one of the big concerns. There's also huge problems with transportation, air and roadways and trains. All of those things get delayed. That's also one of the big concerns that we talk about when we talk about air quality. And then something we don't think about too much, infrastructure. Because the air's so bad, there's corrosion and wear, extra corrosion on buildings and bridges and overpasses, and those things are also an expense and another byproduct of the bad air. Back to you.
Yeah, and a major public health issue. Mari Ramos there. Thank you.
Ein kleiner schwarzer Punkt auf der Sonne hat Himmelsgucker in aller Welt magisch angezogen. Venustransit heißt dieses seltene Schauspiel, bei dem unser Nachbarplanet für kurze Zeit einen winzigen Teil der Sonne verdeckt. In Deutschland war das vor allem im Norden gut zu erkennen.
Auf diesen Moment haben viele heute gewartet, den Sonnenaufgang. Seit 4 Uhr morgens steht auch Regina Leubel auf der Aussichtsplattform des Hamburger Planetariums, um keine Sekunde des Venustransits zu verpassen. Ganz langsam wandert der Planet dabei über die Sonne.
Es ist einfach was Einmaliges, was man nie wieder sehen wird. Es ist nicht so optisch nicht so toll wie eine Sonnenfinsternis, aber es ist trotzdem schön, wenn man diesen schwarzen Punkt auf der Sonne sieht und man weiß, es ist die Venus, die da vorüberzieht. Das ist schon was Besonderes.
Der Venustransit, ein äußerst seltenes Himmelsereignis und eines der bedeutendsten. Erde, Venus und Sonne formieren sich dabei zu einer Linie. Im 18. Jahrhundert bereits konnten die Astronomen damit das Universum vermessen.
Man konnte damit natürlich erstmals die Entfernung der Planeten eichen. Man kannte zwar die Entfernungsverhältnisse der Planeten untereinander, welcher Planet weiter weg war, welcher näher, aber die exakten Werte nicht, also wie viele Meilen, wie viele Kilometer, wie wir heute sagen, ist denn die Venus von der Erde entfernt, ist die Erde von der Sonne entfernt. Und das konnte man mit einem Venusdurchgang bestimmen.
Heute wollen die meisten Menschen den Venustransit einfach nur live erleben. Und das weltweit, wie in Südkorea oder Australien. Ein letztes Mal für die nächsten 105 Jahre.
It won't happen again for more than a century. Will you be around for that? Why that tiny black dot there moving across the sun might help unlock secrets of the universe. Speaking of space, the Space Shuttle Enterprise is on its final trek. Moving by barge up the Hudson River, you can see the Statue of Liberty there. We're watching the journey from New Jersey shipyard to a New York museum. We'll be right back. The planet Venus making a rare journey across the face of the sun. Mari Ramos was one of those who watched the event, joins us from the World Weather Center. Now, you didn't look up, did you? Without protection.
Not without protection, never, right? You always have to make sure that you have proper eyewear or at least look through a protected telescope, a solar telescope, before you do anything like that. Michael, you didn't see it?
I didn't know. Sadly, no. I don't know why. I just never got around to it.
Well, I should have called you or something. Well,
You
look,
should
let me
have.
show you some pictures because I took my family. These are pictures. This is my daughter looking through one of the telescopes. This is at the Telus Museum up in Cartersville, Georgia. Really cool. They had about a dozen telescopes out there. That's me. My other daughter, Michelle, took that picture. They were solar telescopes, and you could really take a good view. There were also binoculars and those glasses that you see everybody wearing. And I want to show you this one picture that my daughter, my 12-year-old, took this picture through a telescope. So it was pretty cool stuff. There were viewing parties all across the world. Let's go ahead and roll the pictures of people looking at them through those glasses. Like you said, you have to use the proper protection for any kind of viewing activity. But for the sun anyway, I want to switch gears and I think we have some live pictures to show you, not of the sun, but another pretty spectacular sight. This is the Space Shuttle Enterprise. Let's go ahead and oh, the live pictures are gone. Well, anyway, Enterprise is making, there it is. It's making its view right New York City. You see it there in the background, Michael. This was the first shuttle orbiter. Back in 1976, that's when they completed it, but it never flew in space. Star Trek fans just fought to get the name Enterprise on it. And of course, this became a test flight, a test shuttle. It's going to the Intrepid Air and Space Museum right there in Manhattan. It's going to be alongside the Concorde. There you see it making its way. So if you spot the shuttle like you did right now, you can send your pictures.
Yeah, I always like that story about the name. It was meant to be called the Constitution in honor of the U.S. Constitution's bicentennial, which was on at the time. But you're right, the Star Trek fans mounted a campaign and won it over. Yeah, 16 flights in all, and it's the last one to be put on display.
Yeah, and beautiful, of course, and a great chance for people to go see the space shuttle, this time in New York City.
Fantastic.
Enterprise.
Mari, as always, thanks so much. Always value-adding the show. Mari Ramos there. And we'll have to leave it there here at the International Desk. I'm Michael Holmes. Don't go anywhere. Global Exchange up next after we check the headlines.
Die US-Raumfähre Enterprise ist kurz vor dem Ziel. Das Ziel ist das Weltraummuseum in Manhattan. Das Space Shuttle legt die letzten Meter auf dem Hudson River zurück. Der Weg führte am Nachmittag vorbei an der Freiheitsstatue. Schöne Bilder mit einzigartiger Kulisse. Doch so ganz reibungslos verläuft diese letzte Shuttle-Reise nicht. Erst verzögerte sich der Transport auf dem Wasser wegen starken Windes. Dann streifte das Shuttle auch noch einen Brückenpfeiler. Die Enterprise war im Jahr 1976 als erster Shuttle fertiggestellt und für Testflüge innerhalb der Erdatmosphäre genutzt worden.
Zeit. Und wer beim Anblick der Venus nicht geblendet werden wollte, musste eine sehr dunkle Schutzbrille tragen. Als sich unser Nachbarplanet zwischen Erde und Sonne schob, zog er die Menschen weltweit in sein Bann. In Deutschland war das Jahrhundertereignis aber nicht jedem vergönnt. Während sich Venus im Süden hinter einer Wolkenwand versteckte, ließ sie in Norddeutschland, wie Susanna Santina berichtet, sozusagen alle Hüllen fallen.
Die Hobbyastronomen an der Kieler Förde gehörten zu den wenigen Glücklichen in Deutschland. Ausgestattet mit technisch hochwertigen Teleskopen und Ferngläsern inklusive Sonnenfilter konnten sie pünktlich mit dem Sonnenaufgang das Jahrhundertereignis bestaunen. Die Venus wandert vor der Sonne vorbei. Hier als dunkler Fleck oben rechts zu sehen.
Eine Bewegung der Planeten im Sonnensystem wirklich mit eigenen Augen live einmal sehen zu können, von der Beobachterperspektive aus. Das ist einfach, das ist schon etwas Besonderes, ja.
Ich musste aufstehen, das kann man sich nicht entgehen lassen.
Das fanden auch Millionen Menschen rund um den Globus. In Australien, Neuseeland oder in Asien statteten sich viele mit Schutzbrillen aus, um das Spektakel am Himmel ohne Schäden zu verfolgen. In den USA, wie hier in Los Angeles, strömten Tausende zu den Sternwarten. Wenn man nur einmal im Leben die Chance hat, so etwas zu sehen, dann will man das einfach nicht verpassen. Eine zweite Möglichkeit wird es wohl für keinen von uns mehr geben. Denn der nächste Venustransit wird in 105 Jahren erwartet. Grund für das seltene Phänomen? Die Venus ist nur dann vor der Sonne für uns sichtbar, wenn sie mit der Erde auf einer Höhe um die Sonne kreist. Da die Venusbahn aber etwas geneigt ist, passiert das sehr selten. Umso größer die Enttäuschung bei vielen Astronomiefreunden heute in Deutschland. Wie hier in Heppenheim waren viele im Morgengrauen aufgestanden, aber wegen der dichten Wolken umsonst.
Wir haben jetzt gesagt, wir müssen jetzt gesund leben, damit wir 2117 die nächste Möglichkeit mitnehmen können.
Das allerdings wird kaum klappen. Glücklich konnten sich einfach die schätzen, die einen klaren Blick auf dieses einzigartige Ereignis hatten.
Aber für den hier, da sind die Leute nicht nur scharenweise mitten in der Nacht aufgestanden.
Sie haben sich auch Spezialbrillen gekauft, sind auf Hügel gestiegen und haben im schlimmsten Fall ganz viele graue Flecken am Himmel gesehen in Form von Wolken.
Ja, und irgendwo dahinter der Venustransfer. Aber wie das so ist mit solchen Himmelsevents, man kann sie überall sehen und woanders, kann man ja sehen, hier an dem Foto, hat es auch geklappt.
Nur bei uns war nichts mit Blick auf den Fleck.
Dabei sind sie alle so früh aufgestanden. Sind schon um 4:45 auf eine Halde bei Recklinghausen gestiegen, um live dabei zu sein beim großen Himmelsspektakel. Und dann nix als Regen. Auch eine Gruppe von Schülern ist hier und mag die Hoffnung nicht gleich aufgeben.
Mal schauen, ob man vielleicht noch später was sieht. Also bis jetzt hat es sich wirklich gelohnt, so früh aufzustehen.
Tja, in Hamburg müsste man jetzt sein. Da ist zur gleichen Zeit der Himmel klar und glückliche Frühaufsteher gucken durch Spezialbrillen.
Ja, jetzt ist es auch wesentlich schöner, das Bild.
Sie sehen ein Jahrhundertereignis. Nämlich den Moment, in dem die Venus sich auf ihrer Umlaufbahn genau zwischen Erde und Sonne schiebt. Da die Umlaufbahnen von Erde und Venus gegeneinander geneigt sind, passiert das nur, wenn die Planeten gerade exakt auf einer Linie liegen. Und das kommt höchstens alle 100 Jahre vor, dann aber zweimal hintereinander, erklärt Michael Geffert, Astronom an der Uni Bonn. Das zweite Mal folgt immer 8 Jahre nach dem ersten Mal.
Und da sind beide Planeten noch sozusagen so dicht etwa auf ihrer Bahn beieinander, dass das nochmal funktioniert. Aber bei den nächsten 8 Jahren, da ist es dann schon nicht mehr der Fall. Dann liegt die Venus beispielsweise oberhalb der Sonne und dann kann der Transit nicht mehr stattfinden. Und dann dauert es lange.
2004, vor 8 Jahren also, konnte man den letzten Venustransit beobachten, zum Glück bei klarem Himmel. Davor zuletzt 1882 und 74. Damals beobachteten Astronomen das Ereignis von verschiedenen Orten der Erde aus und konnten so erstmals Distanzen im Sonnensystem genau berechnen.
Die Tatsache, dass im 19. Jahrhundert Deutschland jeweils 5 Expeditionen in die Südsee geschickt hat, um die Beobachtung auf der südlichen Halbkugel zu machen, zeigt, wie bedeutend diese Messungen für die Astronomen gewesen sind.
Heute ist es eher die Magie des Augenblicks, die die Menschen an die Teleskope treibt. An verschiedensten Orten der Welt heute Public Viewing, begeisterte Gesichter. In Nordrhein-Westfalen dagegen nix als Wolken. Menschen, die fast schon ein bisschen trotzig im Regen ausharren.
Wenn es nicht klappt, müssen wir uns wenigstens nicht vorwerfen, wir waren nicht zur Stelle.
Kurz danach ziehen alle enttäuscht ab. Den nächsten Venus-Transfer gibt's erst 2117. Für uns alle wohl ein bisschen spät.
Liebe Zuschauer, es gibt eine gute Nachricht. Es wird morgen deutlich wärmer als heute sein. Wir zapfen ja derzeit die Hitze aus dem Südwesten Europas an, von Spanien. Aber die Luft ist eben ziemlich feucht, deshalb wird es morgen schwül warm sein. Schon am Freitag wird es aber von Westen her dann deutlich kühler werden und die Luft wird dann auch wieder erträglicher und trockener vor allen Dingen. In dieser wärmeren Luft wird es heute Nacht auch schon nicht mehr so kalt. Da sind es morgen früh 8 bis 12 oder zum Teil sogar 13 Grad. Anfangs regnet es noch, es gibt auch anfangs noch mal ein paar kräftige Schauer jetzt in den Abendstunden, aber der Regen zieht nach Osten ab und in der zweiten Nachthälfte fängt es hier im Nordwesten wieder neu mit neuem Regen an. Und dieses Regengebiet zieht weiter nach Osten, aber am Vormittag wird es wohl an der Oder in Berlin noch teilweise sonnig sein, genauso wie in Süddeutschland. Nachmittags ändert sich, der Regen wird dann auf jeden Fall auch die Oder in den Nachmittagsstunden erreichen. Und am späten Nachmittag setzt auch kräftiger Regen hier im Südwesten, im Saarland, Rheinland-Pfalz, Baden-Württemberg ein. Zum Teil sind auch kräftige Gewitter mit dabei, die uns dann auch in der nächsten Nacht noch beschäftigen werden. Es wird wärmer, aber es ist halt schwül warm. Auch in Norddeutschland immerhin 17 bis 21 oder auch 22 Grad. In der Südhälfte 23 bis 28. Und mit Hilfe des Föhns am Alpenrand kann es vielleicht sogar noch wärmer werden. Das ist ein Sturmtief, was heftige Winde bringen wird. Morgen in Großbritannien. Zu uns kommt diese warme Luft, aber Sie sehen es, da regnet es immer drauf. Also das ist die schwüle Wärme und das Hoch auf dem Balkan morgen. Na, das bringt dort eben viel Sonnenschein. Jetzt schauen wir uns noch mal ein Satellitenbild an von einem Sandsturm vor einigen Tagen im Iran. Hier der Iran, Kuwait, Persischer Golf. Und Sie sehen die unterschiedliche Färbung dieses Staubes, der da losgelöst wird durch heftige Windböen. Das können wir uns noch ein bisschen vergrößern. Das ist halt wertvoller Ackerboden, der hier weggeweht wird. Hier ist es natürlich dieser helle Staub. Das ist nur trockene Wüste letztendlich. Temperaturen 35 bis 47 Grad. Ich wünsche noch einen schönen Abend und machen Sie es gut.
Es war wohl der Präsident selber in seiner Rolle als oberster Befehlshaber, der auch diesen Drohnenangriff anordnete. Äußern wollte er sich nicht dazu. Das überließ er seinem Sprecher. Wir glauben, verließ Jay Carney mit wohlgesetzten Worten, Al-Libis Tod ist ein gewaltiger Rückschlag für Al-Qaida. Dass er tot ist, untergräbt die Moral von Al-Qaida und wir sind dem ultimativen Untergang näher denn je. Er war die Nummer 2 des Terrornetzwerkes, ausgeschaltet durch eine US-Drohne wie zahlreiche Kämpfer vor ihm. Das bestätigen jetzt auch pakistanische Geheimdienste. Ein wortgewaltiger Hassprediger gegen den Westen, der bei den Planungen von Al-Qaida eine zentrale Rolle gespielt haben soll. Einmal mehr gerät Obamas neue Kriegsführung in den Fokus. Ferngesteuerte Drohnen, die auf Knopfdruck in Pakistan und auch im Jemen auf Terroristenjagd gehen. Militärisch erfolgreich, völkerrechtlich aber umstritten. Drohnen, die Waffen abfeuern, müssen auf festgelegte Kriegsgebiete beschränkt bleiben. Und Amerika führt doch nur einen Krieg, und zwar in Afghanistan. Auch Pakistan protestierte einmal mehr gegen den Angriff auf seine nationale Souveränität. Wir haben auch Pakistan klargemacht, entgegnet der Verteidigungsminister auf die Vorbehalte ungerührt, dass sich die USA gegen ihre Angreifer verteidigen. Genau das haben wir getan und das werden wir auch in Zukunft weiter tun. Hier in den USA aber erhält Obama vor allem Beifall für seinen neuesten Drohnenschlag. Seine Strategen verkaufen ihn als handfesten Feldherrn. Die Erfolge in der Außenpolitik aber überdecken nur mühsam, dass er beim zentralen Wahlkampfthema Jobbeschaffung gefährlich schwächelt.
Yes, we can. Barack Obamas legendärer Wahlslogan hat einen neuen Beigeschmack bekommen. Denn der Friedensnobelpreisträger im Weißen Haus würde mittlerweile eher einen anderen Titel verdienen. Als Präsident, der eine völlig neue Dimension des verdeckten Kriegs verwirklicht hat. Da liquidieren die USA mit ihren Marschflugkörpern eine Al-Qaida-Größe nach der anderen, zuletzt die Nummer 2 Al-Libi. Dass dabei auch Zivilisten umkommen, nimmt man in Kauf. Da wird das iranische Atomprogramm und vermutlich nicht nur das mit raffinierten Computerviren sabotiert. In beiden Fällen sind die Amerikaner tief drin in der ethischen Grauzone. Carsten Mierke über Obamas riskante Strategie.
Sie sind leise, preiswert und effektiv. Drohnen revolutionieren Amerikas Art und Weise, Krieg zu führen. Per Joystick, ferngesteuert, töten sie Zehntausende Kilometer entfernt, ohne eigene Soldaten in Gefahr zu bringen. Jetzt haben sie im nordpakistanischen Mir Ali Al-Qaidas Nummer 2 Al-Libi erwischt. Ein rhetorisch versierter Topmanager des islamischen Terrors. Al-Libis Tod ist ein weiterer schwerer Schlag für Al-Qaida. Zum zweiten Mal innerhalb eines Jahres haben wir eine Nummer 2 der Organisation liquidiert. Das demoralisiert sie und bringt sie ihrem Ende näher als je zuvor. In der Tat gehen Al-Qaida die Führungspersönlichkeiten aus, nachdem ebenfalls US-Drohnen im Mai den Drahtzieher des Anschlags auf die USS Cole Al-Quso töteten und im November den gefürchteten US-Jemeniten al-Awlaki. Jeder Schlag persönlich angeordnet vom Präsidenten, der sich damit zum Herrscher über Leben und Tod macht. Während seines Vorgängers Bush starben durch Drohnenangriffe in Pakistan 360 Menschen. Seit Obama regiert, sind es fast 1500. Von einem Friedensnobelpreisträger hätte man das eigentlich nicht gedacht. Alle dachten, er würde die Truppen aus Irak und Afghanistan abziehen und ein Anti-Kriegspräsident werden, ohne militärisches Engagement in dieser Region. Ein Irrtum. Zwar wird Obama wählerwirksam seine Truppen bis 2014 aus Afghanistan abziehen, doch sein Krieg gegen den Terrorismus geht weiter. Der Präsident wechselt nur die Strategie. Das Weiße Haus verfolgt jetzt eine minimalinvasive Strategie. Die USA wollen mit ihren Feinden fertig werden, ohne 100.000 Soldaten zu entsenden und Billionen von Dollar auszugeben. Dazu passt Obamas Eingeständnis, er stecke zusammen mit Israel hinter der Cyberattacke auf das iranische Atomprogramm. Mit dem Computervirus Stuxnet wurden vor 2 Jahren zahlreiche Uranzentrifugen zerstört, das Programm um Monate zurückgeworfen. Ein digitaler Erstschlag sozusagen. Obama ein Feldherr in der Cyberschlacht. Alles in allem eine Strategie, die im Wahlkampf nicht ohne Risiko ist. Die Republikaner nämlich zeigen sich unbeeindruckt und von links hagelt es Kritik, vor allem an den vielen zivilen Opfern der Drohnenschläge. International sind die völkerrechtlich zweifelhaften Aktionen ohnehin umstritten, aber zumindest das ist Obama im Wahlkampf egal.
Stramm stehen für den Führer, und zwar sobald man überhaupt stramm stehen kann. 20.000 Kinder im Gleichschritt, angetreten dem großen Diktator zu huldigen. Geliebte Kameraden der Kinderunion, ihr seid die Erben der militärischen Revolution und die Vorkämpfer der Zukunft. Gleichschaltung von Kindesbeinen an, so erstickt man Ungehorsam schon im Keim. Weinen die Kinder aus Ergriffenheit über die Worte des großen Führers oder einfach nur, weil sie so gedrillt wurden? Südkoreas Medien jedenfalls ließen kein gutes Haar an dem Spektakel, verglichen es mit Veranstaltungen der Hitlerjugend. Mit Folgen. Der pummelige Diktator schäumt und droht dem Nachbarn mit Raketenangriffen. Wenn Südkorea rücksichtslos den Zorn unserer Armee auslöst, bellt die Nachrichtensprecherin, dann wird unser Heer zurückschlagen in einem gnadenlosen heiligen Krieg. Wir sind zu allem bereit. Es wäre zum Lachen, wenn es nicht so ernst wäre. Denn Nordkorea ist hochgerüstet und unberechenbar. Man werde Raketen auf die südkoreanischen Zeitungsredaktionen und Fernsehsender abfeuern, droht Pyongyang und veröffentlicht prompt noch die genauen Koordinaten der entsprechenden Gebäude, um klarzumachen, wie weit man schon ist. Das ist eine gravierende Provokation. Unsere Regierung ist ernsthaft besorgt über diese Drohung und wir fordern das nordkoreanische Regime auf, das sofort zu stoppen. Die oft absurd überzogenen Reaktionen des nordkoreanischen Regimes in Pyongyang lösen ja meist nur ungläubiges Staunen, Spott oder Zynismus aus. Wie in dieser amerikanischen TV-Parodie über den Vater des jetzigen Diktators. Aber irgendwie bleibt da trotz allem immer die latente Angst. Das Lachen könnte einem irgendwann mal im Halse stecken bleiben.
We're joining the International Space Station Flight Control Room, the control team rather, in the Space Station Flight Control Room here at the Mission Control Center in Houston. The Orbit 2 team is on console at this time, and they're led again today by Flight Director Paul Dye. He's joined today by Anna Fisher in the Capcom seat. On board the International Space Station, the Expedition 31 crew has been awake since 1 a.m. Central Time, despite being up a bit late last night, staying up to photograph the historic Venus transit. A photo of what that looked like here. Commander Oleg Kononenko and U.S. flight engineers Don Pettit and Joe Acaba as well as European flight engineer Andrei Kuipers and Russian flight engineers Gennady Padalka and Sergei Revin, are now more than halfway through their day. Kononenko, Kuipers, and Pettit have been at the space station since December, and they launched into space on December 21st, docking on the 23rd. Now, with 168 days in space and 166 at the space station, they're coming up on the end of their mission. They're scheduled to return to Earth on July 1st. Their crewmates, Akaba, Padalka, and Revin, still have most of their mission in front of them. They only launched from Baikonur on May 14th and arrived at the station on May 16th, which means they've now spent 22 days in space and 20 at the space station. A couple of weeks after their crewmates leave, Akaba, Padalka, and Revin are going to be joined by what will then be the rest of the Expedition 32 crew, Sonny Williams, Yuri Malenchenko, and Aki Hoshide. Those three are scheduled to launch from Baikonur on July 15th, and they're already in Russia preparing for their departure. Today they were at the Gagarin Cosmonaut Training Center in Star City, taking part in a Russian segment simulation. In space, the day's work has focused on maintenance and crew health monitoring experiments. Don Pettit has been spending a good deal of his time this morning preparing for repair work that he'll be doing tomorrow on the amine swing bed experiment. That experiment is working to determine whether a vacuum regenerated amine system can effectively remove carbon dioxide from the space station's air. But its control unit power handler circuit board has blown a fuse that Pettit's going to be replacing tomorrow. This week's work with the Ryute experiment rack is also continuing. Pettit and Kuipers have been taking turns working to replace a short-circuited power supply in its image processing unit. Pettit did the actual repair yesterday, and today Kuipers is reinstalling the repaired unit into the experiment rack. Joe Akaba is also doing another round of monitoring for the integrated cardiovascular experiment, which looks at how the body's cardiovascular system reacts to being in space. And he's in the middle of a session of the Pro-K diet experiment as well, which is an experiment to see if dietary countermeasures will help lessen the bone loss that astronauts often experience during long-duration missions. And finally, on the Russian side of the space station, the cosmonauts were also participating in several space science experiments. Gennady Padalka was again today scheduled to work on the Kolonovsky crystal experiment, which studies the effect of microgravity on charged particles in a magnetic field, as well as the bar experiment, which looks at different methods of detecting leaks on the space station. He's also got some time set aside to work on an experiment that monitors group activities under spaceflight conditions. That's what's going on in space today, and this is Mission Control Houston.